record. So last time when we did the class, we did a number of examples, and they're all on the Code Studio P5 list. So we started with really simple ones where we just show how to draw something. The main structure will stay the same for the rest of this course as well, meaning we have this setup and draw function, although we will create a couple of functions of our own, which we can do. And then we showed how to work with color, how to work with simple shapes, rectangles, circles, some more complex shapes that we didn't talk about yet, but we can basically draw anything you want, like you can draw an Illustrator. Then we talked about variables. So how we take a position and store it in memory so we can refer to it later. In this case, we can have a variable called x and then constantly update it so it moves, in this case, to the left or the right. How we use it with color. We talked a little bit about the mouse, so how we can use the mouse to draw something. In this case, we use if mouse is pressed to then draw something, where we can use variables like mouse x, mouse y, p mouse x, and p mouse y. All of these variables are built in, so we don't have to define them. These are defined by p5 for us. And then there's a bunch of other stuff that we didn't actually see, but there's lots of examples, all of them with source code, so you can see how they're implemented. And most of them follow this really simple principle. And then we talked about conditions, about the if condition. So what happens if something is, for example, bigger than the width, then we set it back to 0. So this is a really important one. And of course, one we'll come back to today as well, because this is really a core construct of generative design as well, where we make decisions based on some condition, some value, either the X or the Y position. Maybe if somebody steps into a frame for like a camera, for example, if we hear a sound, all of these are conditions that can trigger something in our sketch. Multiple conditions. Then if we are talking about conditions, we have to talk about else as well. So what happens if this happens in this condition, and what happens if something else happens? So else if or else. Hello. Zet u maar, zet u maar. This was an example of a more complex condition. So when we are talking about conditions, we can also combine different conditions together using these ampersand signs, meaning and, or and just. So in this case, it means if the mouse x is smaller than the width minus the size, or the mouse y is smaller than the height minus the size, not or, and. So this is basically what's called a hit test. So we're verifying that whatever happens inside of this mouse position, which is the size of this rectangle. And I just showed you Flappy Bird. So there in that game, it's also important to do this kind of hit testing to figure out if we're hitting a wall or a pipe or not, or if we fall off screen. Those are all conditions. And specifically, those are combined conditions, meaning we have to check not just are we in the same X position as the pipe, but also on the same Y position. So we have to verify two conditions at the same time. So yeah, we can use variables and conditions together, in this case, to check if a button is pressed or not. In this case, if the mouse is pressed and we're inside of that button, so the mouse X is bigger than the size of the button, smaller than the size plus the width, so the other side of the button, and same for the mouse Y, then the button is not the button, meaning we toggle the button, so button is not button. So if button was false, then it becomes true. If button is true, then it becomes false. And so this is a very powerful combination of using conditions on one hand, and then using variables, in this case, a Boolean flag, like a switch, saying you're on or off. And then one of them that we saw for that, well, there's a bunch of them. This is about probabilities, where we already use random for that, but we'll talk about that later. And then we saw this one. which was a very simple script that we wrote where we just draw an ellipse and then we use a variable called vy to increase the y each time. So vy is the velocity, and we'll come back to that in a minute for our new scripts. And then here we do another condition. If y is bigger than height, then we use this reset function that we wrote ourselves. So this is a function that we write, which we can. So we just name them ourselves. These functions are always required. So setup and draw we have to do. These are what P5 is looking for. But then other functions we can give our own names. So reset raindrop basically takes this raindrop thing and then resets it back to its a new position. So it gives it a new y, new x, new vy, so new speed, and then a different color. And this is actually the core of what we're going to do today for the first example, which is to write this Flappy Bird game. But then afterwards, you also see, and this is maybe not so obvious right now, but one of the issues that we have with this kind of code is that we can never do two at the same time. We can never have two raindrops falling, because at that point it becomes too complex. Well, we could do like raindrop 1x, raindrop 1y, raindrop 1vy, and then do raindrop 2x. But at that point, it's much more useful to use something like a list, where in a list we can actually say, we have a list of raindrops and all of them are falling at the same time. And we'll come back to that later, and then we'll give an example of that. And then I think that's like, if you understand the basics of this is where things actually become really interesting, because once you start using lists and data, then at that point you can do much more complex things than the things that we're doing right now. Any questions about last week or what we want to cover today first before we continue? Okay, so then what we're going to do is we're going to use the same approach as last time. Maybe you still have the folder of last time. In that case, you can use them. If not, I will start over and I show you the whole principle. So on my desktop, I'm going to make a new folder called Creative Coding 2. And I will open that folder in Visual Studio Code. So I'll make a new window. And in that window here, I can choose open, or here I can press open folder as well. Select the folder, Creative Coding 2, and then open it. Again, there's nothing in there. That's the point. If you have the previous folder, it might actually make sense to open that one, because you can nicely combine all the scripts together. And then just as last time, we're going to make a folder. And in this case, we'll call it Flappy Bird. So this is a script that we're going to use. So here I can click this new folder button, type the name, and then make it. And then if it's selected, I can press new and then make a new file inside of that. Again, if you already have that file, this index.html, you can just use that one because it's always the same file, always use the same structure, which is this one. And we'll keep that structure here as well. So if you still want to follow along, there's an exclamation mark, meaning we use Emmet to type the basics of our web page. We give it a title, p5, let's call it this one, Flappy Bird. We can do some style if we want. Here it was, we use style inline or as a file, but I can do it inline here. Basically, all I want to do is use display flex, put everything in the middle. Yeah, sure. Like this. Use a background color, I don't know, light gray. Is anything? A height of 100. All right. And then the most important part is in our body tag, we're going to refer to two scripts. One of them we take and is an external script to P5, and the other one is our own script. So here we write script, and if you're using Emmet, you can start typing scr and then select the second option, which is script source. which automatically adds this source attribute. So it automatically knows that this is something that you do commonly. And then it just fills that in. So here you're going to type https://unpackage.com, which is unpkg.com/p5, and that links to those library. So this is nice and short, the way that you write this. That imports the library for us. And then the second script tag that we use is, again, script source. And this one just refers to sketch.js, which we still have to write. We don't have that.
Does it actually matter if your script tags are in your head?
No, in this case, it doesn't really, because there's nothing in the page, but sometimes it does. So the way that the page loads is it loads from top to bottom. And if it encounters a script tag, then it immediately executes it. So imagine that I'm doing this here, and this sketch is looking for a canvas that comes later in this document, like this. If I'm trying to load it here and it's looking for that canvas, this part of the page hasn't loaded yet. So it's only this part. So especially if we're, and P5 actually uses this setup and draw, so it mostly avoids that problem. But if you're doing other things, then this can become a problem because your script is looking for so in this case, it's always better to put this at the end of the body as the last thing. So if you have a header, for example, hello, then you put that first, and then you do all the scripts at the very end. So then the sketch can refer to these elements because this is already loaded before it's loading the scripts. Good question. So now, of course, we need the sketch. So we're going to make a new file, sketch.js. The main thing that we want to do in Sketch is have two functions, setup and draw, function draw. And in setup, what's important is that we create this canvas. So we're going to write create canvas 400 by 400, which is our Flappy Birds canvas. And in draw, let's already draw a rectangle. And then I can open live server, see if I can get any output of that. So I should see something like this. Yeah.
Can you really explain setup and draw again?
I just had a question about the setup. You always need the setup.
Yeah, because if you don't actually make a canvas. So setup is needed because here we have to define what the size is going to be of our canvas. If we don't do it, the system doesn't know what our size is going to be. And so, yeah, it doesn't actually work. Let's try it. So if I open this in Firefox, so if I don't have a setup function, and I put it in comments here, it does actually work. So what you see here is that the canvas now is actually a default canvas of 100 by 100, which yeah. So it might not be what you want. Yeah. So this is like a. So most of the time, so the important thing about setup and draw, and the reason why we use it is that in setup, we do things that we only need to do once. So draw runs constantly. So draw keeps running all the time, and setup just runs once at the beginning of our script. So in this, we mostly do setup things, and then in draw, we do the actual drawing of the thing. All right, so let's draw our Flappy Bird here. So this is our canvas, right? And if we think about it, our bird starts out in the middle of our canvas. So here, our rectangle, this is the X position of our rectangle. Imagine that this is my bird now. So I'm calling this, add a comment, it's always useful, draw bird. So the rectangle is a rectangle. So the size of the bird is, I'm just going to constantly peek a little bit at the example that I wrote, just to make sure that it matches what I did before. Okay, so the bird itself is 10 by 10, but where does it have to be located? So the X position of the bird is somewhere in the beginning of the of this. So yeah, I assume everybody knows Flappy Bird, but so you see the bird is actually somewhere here, and then you have all these pipes. In this case, it's or what's obvious in the game is that the bird actually never moves, or it only moves up and down, but it never moves sideways. It's the pipes that actually come up to us. So we get this illusion that the bird is moving, but the bird actually never moves. So the X position never changes. So we can set it to a fixed value, but what should that fixed value be? Well, we can try something, let's say 50. I don't know, 100, maybe that's a nice location. And then the Y value, of course, that moves, that changes, because the Y value of the bird always is different. And in this case, the Y value of the bird should probably be at the half of the screen. So we can take the height, which is a built-in variable and refers to the height of the canvas, and divide that by 2. And that will place the bird in the middle. Actually, if we want to be really certain about it, it doesn't actually place it in the middle. It places the top left corner in the middle and then draws from there. But that's fine for us. It's just to know that, because it's not so fast. So if you really want to do it in the middle, we do height divided by 2 minus 5, because the rectangle itself is 10. But that's just to know for sure. Now, of course, the first thing that we want to do is we don't want to draw the pipes. We just want to make the bird move. And so if we think about that, it probably makes sense that the height can't always be the same. The height needs to vary, right? It has to change. So we probably don't want to have this fixed here, where it's always the height divided by 2. Instead, we want to make a variable that contains the height of that bird, or the position of that bird. And then we're going to do that at the top here. So before we start our sketch, we're going to make a new variable. And we'll use let here because the variable changes constantly. And we'll make one. So we'll do bird underscore X. So that's the X position of the bird. That doesn't really change, but it's nice to have that there as well. And then we have bird underscore Y. So that's going to be our Y value of the bird. Like this? Yeah, sure, no problem. But I'm going to do much more. So these are the beginning, but you'll see here I have much more of these, so it's nice to put them together. And then what I want to do is I want to, basically when I'm setting up, I want to set these values to a first value. And here I'm already going to do something that now seems a bit excessive, but we'll need it later, which is I'm going to make a function called reset. So like we did with the raindrop, whenever something happens, so whenever we have game over, we basically have to reset the value of the bird to a new value. And we want to have this reset as well. I want to stress again that reset is not something that's built in. It's a function that we defined, a name that we defined. It's probably also not the best name because I think it's built into p5, but whatever. Yeah, maybe we should call it reset game. Yeah, then it's clear that it's our own thing. And so what reset game does is it sets the value of bird X to, let's say, the width divided by 4. So somewhere in like 0.25 of the screen. And then the bird's Y, it's going to set it to height divided by 2. Now, just because we made this function doesn't mean it gets called anywhere. We just defined it, but it's not being called. It's only until we call it that that it works. So in setup, we're going to at least call it once. So here we're going to say reset game. So setup is going to create a canvas and then reset the game, basically start up the game in this case. And that's going to populate the X and the Y variables with the names that they have to have. Cool, but now we still have to do something here. So here for draw bird, what we're going to do is set bird X and bird Y as the 2 first values because we need them here. If all goes well, it's still the same thing. So there's still this going on. But now we can actually start manipulating these values. And now we come into the interesting part, which is jumping or flapping, because that's what the game is all about. So when do we have to flap? Or let's say differently, in Flappy Bird, what's happening? What's going on with the bird? There's two opposing forces that take place. What are they?
Like thrust and then gravity.
Yes. So the bird, so gravity is constantly pulling on the bird, dragging it down. And then it's up to the bird to provide thrust, basically to flap, to make sure that it goes up. So these are the two opposing forces that we have to take into account. So every frame, we're going to apply gravity to the bird. And then it's up to us when we press the mouse or we press a key to actually provide thrust. So to move the bird up, 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 up. The way that that works is through Newtonian physics. And I'm not going to scare you too much, but there's a really, really interesting post or chapter in the Nature of Code that talks about this. And the basic principle is here in forces. So there's this whole Newton's first law, but these are things that we intuitively understand. So if an object is still, it stays still until a force is applied to it. Like if there's a ball, it doesn't move until we kick it, right? Or until there's some other force, like wind, for example, blowing the ball away. We know that. The second rule is that if an object is in motion, it will stay in motion unless there's another force that acts on it. So a ball, if a ball is rolling down a hill, it keeps rolling down a hill until there's another force, like a wall that blocks it. Or if there's a ball rolling, there's like friction applied to which stops the ball eventually. But if that ball will be rolling in space, for example, there's nothing stopping it, so it just keeps going. That's the second rule, right? So if it's still, it stays still. If it's moving, it keeps moving. So there's this velocity that's constantly moving the ball, this force that's constantly moving the ball that gets applied. So every frame, we have to apply this constant force. But there's these forces are, so we can introduce new forces, and which is what we do if we flap the bird, then we introduce a new force. We basically provide thrust, so we move the bird upwards. And every frame, there's another force that gets applied to it, which is this downward force. Yeah, so there's this all these things. There are opposite forces that we don't really talk too much about that. But basically, there's one really important thing here in all this code. This is actually very, very interesting to read. We're not going to go all the way through it, but you see there's all these nice examples. So I really recommend going through it and understanding what's going on. But what we really care about, so we don't care about air fluidity and gravity and resistance. Where's my main? There's one very simple formula that I'm looking for right now, and I can't find it. This one, I think. Still too complex. Okay, I'll write it by hand. Doesn't really matter. So, but we can try deducing it ourselves and try to figure out if it does what we think it's going to do. So here's our bird, and we're going to implement flapping. So we're going to say whenever we press the mouse, so function, we make another function mouse pressed. This is actually a function that P5, where the name is important because P5 refers to this name, mouse pressed. Whenever we press the mouse, it's going to look for that function. And if it's there, then it's going to call it. If it's not there, it doesn't really matter. It doesn't do anything, of course. But if we have a function mouse pressed, it's going to call that function. And so what we need to do here in this function, or what we can try to do, is say, well, the bird.y. So we provide thrust. Okay, what we need to do? Well, we are going to move the bird. So we move the bird upwards. Remember, we're actually drawing from the top here. So if we want to move the bird upwards, what we do is we take our y position and we decrease it. So we do minus equals 5, for example. So now if we click, we see that every time we click, this happens. This is like the most unsatisfying Flappy Bird ever. Because this is not how we expect this to happen, right? We expect what to happen is that the bird then moves downwards again, because there's this counteracting force, this gravity that's applied to it. So this is not enough. Instead, what we need to do is we need to add this value as a force to the velocity. So we're going to define a second value here, which is bird. And I think I did it for the two of them, bird Vx and bird Vy. Now what's Vx? This is the speed that the bird moves in. So whenever the bird is moving, we want it to move both in X and in Y. Now remember the X value, the bird actually never moves in Flappy Bird, but we can use this bird Vx, so the speed that the bird is moving in X, which is constant, and it's always moving at the same speed. We can actually use that to move the pipes in the other direction. So the pipes actually come up to us with the speed that the bird moves. So it gives the illusion that the bird moves. So that's this Vx, the velocity of X. And Vy then is the speed that the bird moves in Y, so up or down. So let's try something else. So here in our code, what we're going to do is we're going to, or in reset game, let's do that first. We're going to set bird Vx, so the speed at which the bird moves with X, we're going to set that to 2. And bird Vy, we're going to set that to 0. So it stays still here, but moves in X. So for example, if we do here, if we make a function like update position of bird, normally what would happen is that we would say bird X plus is bird Vx. So every frame, we take the velocity and we add that to X. And we do the same for Y. So we take the velocity and we add that to Vy. This is this second rule of Newton's laws, which is that an object in motion stays in motion. So if there's a velocity applied to this bird or a ball, every frame we apply that same velocity so that it keeps moving. This is the second law. If we try this, what happens is that our bird now actually moves from left to right until it falls off screen and then just keeps going. There's no way to stop it. You can check that that's correct. And please tell me if you get an error here. So if you get something wrong, for example, you made a mistake or something, I have the developer tools open and I will get an error here where it says, well, I have this problem here at line 21, and then I will go check at line 21 and check if that's correct. But this is what should happen, right? The bird should move off screen. But again, this doesn't really happen in Flappy Bird. The bird never actually moves off screen. So this line, we don't actually want to do, but we want to do it for Y. So let's try it. So instead of, imagine that there's only one force, the bird is in space, so it flaps with its wings. What needs to happen is instead of updating Y immediately, we're going to update the velocity of Y. So we're going to tell the bird to change its speed immediately whenever we flap with our wings. So let's try this. So we say Vy, and we don't want to say it equals, we wanted to do it like this. So bird Vy equals -5. So every time we flap, we're going to set the velocity -5. So now if we click, what happens is that the bird moves up, right? This is already a start because we click, and because there's no gravity, the bird just keeps flying up, right? That's a start. It's not enough yet, but that's a start. Now, as I said before, and as Ezra pointed out as well, there's two forces applied to the bird. So there's, on one hand, there's velocity. On the other hand, or there's thrust, so upward thrust. On the other hand, there's gravity pulling the bird down. So how do we model this? Well, it took me a while to figure this out, but that's why this nature of code is actually useful. They actually provide a third layer here, which is the acceleration. So every frame, we're going to basically take all the forces that apply to it and we add them together. And then we take those forces, we limit them in speed, and you'll see why. and then we apply them to the velocity. So the velocity is constant. Again, an object stays in motion until there's like a force applied. So an object in motion stays in motion. So our velocity stays constant, but then we apply these forces to them. So we do something extra here. And I'll apply it and it sort of starts making sense, I think. So there's a different layer or an additional layer, which is bird AX, and AX here stands for the acceleration, and bird AY. So what's crucial here with this acceleration is that this acceleration gets reset every frame. So every frame we have to define which forces apply to the bird. We apply those forces to the velocity. We apply the velocity to the position, and then we reset the acceleration. So it's up to the next frame to say, okay, now what are the new forces that take place on this bird? And we do that here. So here for updating the position of the bird, we're going to say, well, the bird Vy equals, or we add the bird AY to it. So we add the acceleration, the forces to this bird. And what are these forces? Well, the first force, and this is something that we haven't done yet, is we add acceleration or gravity. So we say bird AY plus equals, so every frame we add a bit of gravity. And so the gravity, again, moves us downwards. In this case, it means that the Y position goes down, the Y position increases, so our bird goes down. So to add acceleration, we do, I'm going to write here add acceleration. So that's a force. And the bird has like a 0.3 acceleration. Versnelling? All right. Then we take this acceleration and we add it to Y. And then really importantly, at the end, so when we have applied these forces, we say bird AY equals 0. So we are going to reset our acceleration force at the end, and it's up to the next frame to apply these new forces. And that's important because this thrust only happens whenever we click, right? It doesn't constantly apply to this velocity. So the thrust or the flapping of the wings actually happens only one frame. It pushes the bird upwards, but then gravity is constant. It constantly drags the bird down. I'll put these together a little bit so you can see it a bit cleaner. So this one means add acceleration to velocity. And again, this one we don't actually use, we don't move the birds. This one means add velocity to position. Reset. Now, believe it or not, but we basically implemented Newton's laws of physics in a couple of lines of code. And now, if we still have to change this mouse pressed here, but now we will see immediately that working with the bird feels much more natural or feels much more satisfying. So our acceleration, what we do is here in mouse pressed, we're not going to change the velocity immediately because we really can't. We are actually applying a force. So we're going to say bird AY, which is acceleration force, minus equals. Remember, Y goes down. So we want to go up with our bird. And here we just provide a value like 20, for example. And now if we save and we refresh, we should actually see the bird, but maybe it's a bit too fast. Oh yeah, and sorry, here in reset, we also want to do a x equals 0 and bird a y equals 0. Yeah, cool. And now what should happen is that we can play a little bit with this bird. You see, it's not perfect yet. Maybe if we flap a couple of times, it just never comes back. So there's another thing that we have to do. Yeah. So a couple of important things here in reset game. Note that we reset everything here, everything that we defined here at the top. So we need a value for x, y, vx, vy, and ax, ay. In draw, what we do is we add gravity. It's not acceleration, it's actually adding gravity. Then we're adding the acceleration to the velocity. This applies these new forces that come up every frame. We apply these new forces to the velocity, and then we take this velocity and apply it to the bird, to the position of the bird. And then we reset our acceleration. This is kind of tricky if you've never done this before. Again, I recommend that you read the chapter in the nature of code if you want to learn more about it. But this is also the way that they implemented in Flappy Bird, and I think it's a really clean way to provide something that where you can do a jump and it just feels satisfying. And then also remembering Bird in Mousepress that you take this acceleration force and you have this upward force, right? This is our thrust here. Yeah, so you have to refresh and then you have to click. So it already feels sort of like a game, right? So to keep the ball somewhere on screen.
But yeah,
yeah, you can change this flapping. Yeah, but before you do, there's one important thing that we need to add, and that is that the bird is not infinitely fast, and that is so we want to limit its speed. So we can't just keep clicking and have the bird move upwards forever. Instead, what we need to do is we are going to add another line, which is limit speed or limit velocity, actually. So we apply all these forces, but then at some point we run into like physical limits. And these are the same here. So we say bird vy equals constraint. And constraint is something that's built into p5. And constraint is going to limit this force. So we take bird vy and we say a minimum and a maximum value where it can lies between. So constraint basically takes this value, and if this value falls between the constraints, so the minimum and the maximum bounds, then it doesn't do anything with the value. But if the value is smaller than the minimum, it's going to limit that to the minimum. If it's larger than the maximum, it's going to say, no, it can only be this maximum. And this maximum is for us is important. So our constraint is going to be something like -5. So the maximum speed that can go upwards is 5 and downwards is 5. Note that we don't actually do things like meters a second or something. So here gravity is like 9.2 meters per second, but we don't actually have these values, right? These are fictional values that just, if they feel right, then it's fine. And now you'll see it's much more easy to control this. One thing that you notice, so is this working for everybody, the limit constraint thing? Do you notice that it works differently now? Yeah. All right. Any questions about this part? This is, I think it's super cool, especially if you're trying to model something like natural forces or something, using the system of acceleration, velocity, and position actually means that you can implement things like wind, or you can have drag or friction where a ball sort of comes to a stop naturally, or you can drag something and sort of moves around the screen but then stops gradually because there is this friction. All of these forces just work really nicely just by adding them here to this acceleration. So I think it's a really nice system to work. What I want to do, and you probably noticed this as well, is that immediately when we load the game, it just falls down, which is not what happens in Flappy Bird. So in Flappy Bird, it just waits until we actually start playing with the mouse, and then it starts moving. So we're going to add something else here, which is we're going to add a variable, let playing equals, and we're going to set that to false initially. So we're not playing the moment that we load our sketch yet. We only start playing the moment when we click the button. And so what this implies is that this playing basically means that all the forces that we now just carefully defined don't actually work until we start playing. So here, what we are going to do in this code is we're going to wrap all of this updating, but not the drawing. So the drawing, we can draw the bird, whatever we want, but we don't want it to move yet. So all of this code, we're going to put in a condition. So at the top here, we're going to say if, between brackets, playing. Then we open the bracket, and then this closing bracket here. So this one that goes all the way until after the forces. So this is the part that now becomes this condition. And if you have prettier setup, it's going to reformat this so you can see which part comes inside of this if playing. And now you'll notice that I can't do anything anymore because well, the mouse is not working. We haven't said when it should start playing, but we can do that now. And so in Mousepress, what we're going to do is whenever we press our mouse, then we're actually playing. So here we're going to say playing equals true. And now if we start clicking, then we actually move. So initially nothing happens. Now if we start clicking, then we actually play the game. All right. Is this starting to make sense? Sort of what we're doing. We're not seeing new concepts generally, but instead what we're doing is basically reiterating on concepts we saw last week and slowly building up a game. And you see that there's a bunch of stuff that we need for a game. One important thing when we are playing a game as well is that we need to know when the game is over. So we have drawn the bird here, but here at the end of our draw function, I'm also going to check if we did something wrong. And in this case, there's no pipes to hit, but we can actually fall off screen. And in that case, the game is over. Right? So that's something that I do want to implement. And so what I'm going to do here is write a condition where we say if, and now we have to check. So what is this condition going to be? So how do we check if the bird is off screen? Yeah. So if something's lower than something else. So what do I have to type here? Yeah. So if bird Y, this is the vertical position of the bird. Nothing can happen with the horizontal position. So bird X, there's no check that we need to make because it doesn't actually move in that position. So lower than height. Does this work? Seems like a loaded question. Remember, so we think of this as lower, but remember we're actually drawing from the top. So our bird Y, if our bird Y is 0, we actually start here at the top. And then here the height is 400. So our bird Y, if we only let gravity apply, so gravity adds to this bird Y value. So it's going to go like first in the middle, so 200, 205, 6, 7, 8, 9, until it reaches like 400, 450, 500, 1,000, and it just keeps dropping down. So what we call lower is actually higher in this case. So bird Y, if that's higher than the height, meaning it goes below the height of the screen, then the game is over. Then and now we have to think about, okay, what does that mean when the game is over? Well, it can mean a bunch of things, but in this case, what we're going to do is we're going to make a variable because we need it later called game over. We're going to set that to false. And then if the bird Y is bigger than the height, then game over becomes true. The reason why we do it this way is because there's another condition that can happen where the game is over, which is the condition where we hit a pipe. We don't have pipes yet, so this is not an issue here, but this will come back later where we actually have two ways that the game can be over. Either we fall off screen or we hit a pipe. In both cases, the game is over. And so what needs to happen if the game is over? Well, if we can do it here, if game over, then we are no longer playing. So playing equals false. And now we can try this. So we can move, we can play, oh, we fall off screen. But now if we click, it's kind of funny, it sort of drops from the bottom. It's like, hey, I'm still here. Because the game is no longer updating, but it just moved right here. So right down, the game stopped playing, and then nothing is applied anymore. That's not really what we want, right? We want, if the game is over, we want to stop playing, but then if we press the mouse again or we do something else, we reset, then we want the game to reset. So basically, and that's why we wrote this reset game, basically we want all these values to turn back to normal. So we want the bird in the middle, we want the Vx to be here, and so forth. But maybe, so we can do it here, like this. So we move here, but now the bird is here immediately, which is not really what I want. So instead, I'm going to leave the bird wherever it is. But here in Mousepress, what I'm going to do is I'm going to say if, and this is new, if I'm not playing, so the game is over, then I'm going to reset the game and set playing to true. And this actually is quite nice because now I can click, I can wait. I probably want to show a game over screen, and then I can click again and it's going to reset. So here, there's another thing that I want to do in game over, which is to put some text here. So I'm going to say text, oops, text with lowercase. Note that Visual Studio Code sometimes completes this in a weird way. And I'm going to write game over. And the position where I want this text to be is basically centered on the middle of the screen. So width divided by 2 and height divided by 2. So if I click, whoop, the text is here. But you see it's not really centered because text normally aligns from the left and not from the center. So before we do that, we can type text align center, and that's going to align our text. And maybe also font size. I'm not sure if that is a thing. Text type. And that text stays on the screen until we press our mouse, and then it's going to reset. Yeah. Try also to think a little bit about the logic. Yeah? So every step that we're doing here has a reason why we implement it. There's like a logical sense that we are applying to it. So try to follow that reason as well. Echt? En staat dit bij reset game allemaal? De X, de Y, de VX, VY, dat staat allemaal juist. Hè?
Ja.
Ik wil eens komen zien, zeg het wel. Ja, ja. Ah, wacht, dat ken ik niet. Zou je dat zien of moet het groter? Dat gaat, hè. Maar zie je, je hebt niet.
Ja, dat is misschien.
Ja, maar het is die eerste vlees, dat we dat je gewoon niet complete voor. Je word staat in die frame. Dus die kan enkel betekend worden als die was gaan spelen. Die attent op zijn gaan spelen. En nu is het terug. Het helpt van zo, want het zijn eigenlijk allemaal onderdeeltjes met code. Maar dan misschien te labelen. Dit zijn de dingen waar je bijvoorbeeld tekent. Dit zijn de dingen waar je mee bezig bent met bewegen. Position, dat is bewegen. Dat is tekenen. En dit is ja, checken of dat gaat vinden. Ik zou beweging van boven zetten, omdat je op het moment dat je tekent, dat je eigenlijk de laatste beweging krijgt. Dus die beweging is stil, dat je dan doe het 100 keer, de tekening gaat voor je. En dan geef je bingo. Ja, dat hoeft niet per se, is dat ook hier achter. Voor mij is dat logisch dat die gewoon op het einde komt van die code. Verlies voor jou. Dat komt er. Ja. Ja. Ah ja, maar ik is komen als een boven verschillende staan. Dus waarschijnlijk het helpt als je die misschien wat is er niet ja, dat je naar de mensen op als er dan een fout is, dan waarschijnlijk heel de tijd. Ja, het is, ja, maar hij voelt niet uit. Dus nu gaat het gaan. Dus dat is je denken wat ben je bezig. Maar dat moment dat je een bepaald stuk gaat komen, dan moet je daar. All right. Next, let's make it a bit more exciting, which is that we're going to add something to the game itself, the pipes. And here, so initially, if you look at the Flappy Bird, this is a bit excessive maybe. But in the game, you have multiple pipes on screen. We can't actually do that yet. There's a limitation because we don't have a list. We don't know what lists are yet. So we don't have a list of where all the pipes are going to be on screen. Instead, what we're going to do right now is just going to make one pipe and just have that one pipe move from the right of the screen to the left of the screen. And then once the pipe is off screen, we just reuse that. So we're going to put it back at the end, sort of like giving the idea that there's a new pipe, and then just move that pipe up.
right? So let's do that first. So we're going to make a pipe X and pipe Y. This is the position of that pipe. We don't want to do all the rest of it. So we don't want to need, we don't need a pipe Vx and a pipe Vy. The pipe itself is not, doesn't have forces to apply to it. The only force that we apply is the bird Vx. So we're going to move the pipe based on the speed of the bird itself. But it's not enough, because if you look at Flappy Bird, you see that we have all of these different pipes. They all have a gap between the pipes. So the pipe is actually consists of two parts. So it's not enough to know an X value and then a Y value, because also what's the Y value of this pipe? It's all over the screen. But it sort of makes sense to have this position of the gap, so know where the gap is. Maybe the width of the pipe as well. Maybe we have wide pipes and small pipes. We can do that as well. In this case, they're all the same. But the gap sort of makes sense, right? So we have to do like pipe gap, which is the size between the two parts of the pipe. Iman actually had a nice sketch of this. What?
You have the picture.
I have the picture somewhere. See if I can find
Should
it.
I draw it here?
Yeah,
Something like
sure.
So, so this is your canvas with musicians. You have to create two rectangles essentially.
Yeah.
Well, I do it kind of differently, so I'm not sure.
No, go ahead, go ahead.
The thing is that you draw your pipe here off screen so that it moves backwards, so that you can create movement. So it always starts here, and that position is the width of your
Or the X position of the pipe.
X position, and then 0, because our starting point is always this one, and it's always starts at 0, 0. So if I want to be here, I just need to move my X to the total width, and then my Y value the same, right? And then for a rectangle, you have your X, your Y, and then your width and your height. So I will create a width to make my rectangle. So I don't know, let's say 5 or 10, and then we need another coordinates to create our rectangle, so they go down. So I call this the top, and then we need another coordinates to create the other pipe. So we call this bottom, and they always start at the same point, right? But then you have this gap that needs to shift constantly. Well, in my example, I have like multiple pipes, but in this case, it's going to be one pipe that has a random gap every drop, every iteration, essentially. Is this clear?
Yeah. So how do we calculate them? That's the question.
Yeah, well, the calculation is you generate a random number for this, and you generate a random number for this, and then this becomes your
You can calculate that basically.
your top. Wait, not this one. The height minus the top minus the bottom. So this entire thing minus this part minus this part will become.
Awesome.
It will become clearer when you see it.
Okay. Yeah, so that sort of makes sense. So we have our pipe X, which is, as Iman said, is initially going to be off screen. So in our reset game, you can actually write already pipe X equals the width of the screen. So that's going to be off screen, immediately off screen. Pipe Y, well, Iman actually called it differently. So they call it pipe top. So we probably want to do that as well, pipe top. And then pipe gap is the space between the pipe. The top and the gap are random values or can be random values. So pipe top is whenever we start a new game, it's going to be a random value. Where can that top appear? Well, it can appear all the way at the beginning. and then it can sort of appear down, 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 but not all the way down. So probably between 0 and like the height divided by 2 on the screen. And then the gap between the pipe is going to also be a random value. And that random value can be between a very small, tiny section where we have to move between, or a very large one. And again, this is something that we can try out. Let's try between 50 and 100 and see what that gives. All right. Now, to actually make sure that we can draw the pipe initially, because we don't move it yet, what I'm going to do right now is not use the width here, but use something like the width divided by 2, which means that the pipe is going to be in the middle of our screen, just for trying out, because we can't move it yet. So this is just for testing right now. So we'll have to change this later. Just for testing. So in draw, we draw the bird, and then after drawing the bird, we draw the pipe. So here we say draw pipe. Pipes are green, so fill green, and the bird itself is blue. So we draw the pipe in 2 segments. The first segment is from pipe X to 0. So at the top of the screen, that's where we move from. And then the width of the pipe is a fixed value. So we don't have a pipe width yet, but say that it's always like 50 pixels or something. This is actually not the best idea, because we need to refer to that later. So when we're moving through the pipe, we need to make sure that we actually know when we hit the pipe. And then we also need the 50 there for checking that. But then this 50 sort of doesn't mean anything. It's like a random value. So instead, what I really like to do here is also say pipe width, even though that this value never actually changes. Here we can say pipe width equals 50. And that it's sort of makes it clear what this value is going to be. So it's not this random 50 that just appears out of nowhere, but we know what it means. So here we do pipe x0 pipe width, and then the height of the pipe is this pipe top. So that's what Iman just drew from 0 to the top of the screen. So that's our first pipe. And again, we can already verify that this is working. So this is our first segment here. Does it work? No, nothing. Okay, there's 3 things that we need to do. We need to define these things here, make sure that they're correct. Pipe X, pipe width, pipe top, pipe gap. We set our pipe X to width divided by 2 in this case. If this is just set to width, as I said before, then you won't see it because it's off screen. So that's why I have width divided by 2. Then I have the width of the pipe, so the size of the pipe itself. Then I have top, which can start at 0 and go to height divided by 2. If this is really small, probably 0 is too small actually. But if this is really small, you don't actually see the top part because it's just all the way up top of the screen. So you might not need to reset. Or in this case, what I need to do is set a random value to something like 50 as an initial value. Until height divided by 2. And then the gap is also this random value. So now, every time I refresh, I get a different pipe or a different length of pipe, as you can see here. Still not working? Yeah. Okay, what was the mistake? Ah, yeah, okay. Okay. So make sure, that's also why I have this console open all the time. Make sure that you have that as well, because if you make a mistake here, for example, you don't define it, you might get an error. No. Good point. So in this case, and this is something that's a bit stupid in JavaScript, but here now pipe width is actually set to nothing, undefined. There's no value here. But JavaScript doesn't care. So it's drawing a pipe with a value of undefined. And in this case, it interprets undefined as 0. So the width of the pipe is 0, which means there's no width at all. So it's not drawing it at all. So sometimes you get an error. For example, if I make a typo or something, for example, if I write pipe width like this, then it's going to say, well, I don't know what that is. But in this case, pipe width is defined, but actually it's undefined because we didn't put any value in there. Okay, and then the next pipe, here we have to think about it. So the X position is the same, right? Pipe X, that's the same. But the Y position, so where we start drawing the next part is different. Here in this case, we want to draw, basically we want to leave the gap open. So I'm going to show it again. So we want to leave this gap open, but then we want to draw our next part. So we have to go from this value, which is pipe top. We add the gap, so this empty space here, and then we start drawing. So our Y value here is pipe top plus pipe gap. So that's our X value, our Y value. Our width is the same. Our bottom part of the pipe is just the same width as the top part of the pipe. And then for the height, so how high is this pipe? Here's where we can do a little trick, which is we can calculate this, or we can just make a very big value because it will fall off screen anyway, so we don't actually see it. Or we can just say height, maybe that's a bit cleaner. So we draw too much, but we don't actually see that part, so we don't really care. The correct way to do this is to take the height minus pipe top minus pipe gap. That's actually if you want to do it correctly. And now it draws until this very end, but because it all falls off screen anyway, we can just write height and that will work as well. There's a tiny bit of difference that you see here. There's actually a border around it here. And if we use height, this border disappears because it's not finished yet. So if you're really sensitive about that, you can do it the correct way, which is like this, but you don't have to. So now if I do it this way, height minus pipe top minus pipe gap. Now you see that I have this border here as well. Again, maybe not the most important thing in the world. All right, so we moved our bird. Now let's move our pipe. Remember, the bird doesn't actually move, it's the pipes that move. It's sort of the other way around. So what that means is that the pipe X is going to move based on the speed of the bird. So our pipe X, so this starts out at width, is going to decrease. The value is going to become smaller. So the pipes moves from the right to the left. And we are decreasing that value with the speed of the bird. So the velocity in X of the bird, not the Y. The Y is actually really funny if you want to do it that way, but it doesn't really work. So now if we start playing, we see that we have the pipes. Of course, they don't react yet, and they just move off screen immediately, but that works. Right, so this one line moves the pipe and sort of gives this idea of a, or illusion of a game. Although we probably here for the pipe X, now we probably want to set the pipe off screen, so set to use width here. So the pipe moves off screen instead of moving immediately right onto the bird. And now we can try playing the game, but there's only one pipe because the pipe just keeps moving off screen forever. Okay. Yeah. So you need this rule, pipe X minus this bird Vx, to move the pipe based on the speed of the bird. And then here in reset game, we are going to have these values here, where pipe X equals the width, so it's right off screen. And you can actually see it a tiny bit. So if you refresh, you can see that there's this tiny line because we are actually drawing the stroke of this pipe. So it's not really, it's right off screen. So here it would make sense to use width plus a value like 100 or something. So it falls off screen, but it's like a little bit more off screen. Right, and now if we start playing, now you can see that we actually have this and it feels playable, even though we just can go right through the pipe because there's no check at all. Yeah? Theme? Ah, ja, ja, ja. Je mocht ook dichter komen zitten, hè? Zo makkelijker is.
I'm moving.
Oh, yeah, okay, this is, yeah. Move the pipe. This is the important part. And then here we are also going to write a condition. So if, and what does the, how do we, what are we checking for here? So what do we need to check? If something. Yeah. So when can we show the next pipe? Again, remember, we only have one. So when can we do it? Right now, right? Yeah. So if the pipe falls off screen. So what that means is if the pipe X plus its width is smaller than 0, that means that the pipe is fully off screen. So we take the pipe X, we add the width to it, because otherwise we still see a part of the pipe. And then if that's smaller than 0, then it's time to put a new one on screen. Remember, there's not actually a new one. We're just reusing this one, right? We're just quickly moving it to the other side of the screen. And let's do it very quickly. So pipe X plus equals width. That just resets the pipe here. So now we can play here. It moves off screen, and now it just immediately comes back. Right? It's the same pipe, just over and over again. But also, that's the problem. It's the same pipe over and over again because it doesn't move. It doesn't go higher or lower. It's just always at the same position, right? So this part is kind of boring, right? Because it's always the same thing. So here it would make sense to actually set the pipe top and the pipe gap back to its original position. So we can also copy this part of the code and paste it here. So the pipe top is now different and the gap is also different. And now we have something that resembles sort of like a Flappy Bird game. So I just copy and pasted these lines from here, right? They're the same ones. And now if we start playing, we see that we have a pipe here. And the moment it moves off screen, we get a different pipe and we sort of have to move up there. Or we just ignore the whole thing because nothing gets checked anyway. So we can just go right through it. And maybe a gap of 50 is a bit ambitious because it's really small. So here for the pipe gap, we probably want to make it a bit larger, like from, let's say 80, I don't know, till 120 or something. And then also remember to do the same thing here, like this. But we already got pretty far in this 1 hour and a bit of coding, which is we have the bird. It feels nice to have this jump instruction. We have pipes moving across the scene. It seems like infinite amount of pipes, even though it's always the same one. We can draw the whole thing and we can do a game over when we fall off screen, but not yet when we are checking for the pipes. So we're already pretty well ahead in our game. Do you need a break at this point or are you able to continue? There's a couple of things that we need to implement. So one of them is checking if we hit the pipe and then also adding score when we are past one pipe, we need to add score and then we're done basically. Okay, that's cool. So we do a 10-minute break and then we come back here. Resume recording. Now for the interesting bit, which is the score and the verifying if we actually hit a pipe. So let's think about it a little bit. So when are we actually losing? Well, if you think about it like this, there's two conditions that can happen. One, we only can hit a pipe if we are at the position of the pipe, which makes sense. But if we're at the X position of the pipe, so if you're right between these pipes, or like here, for example, nothing much can happen, right? Because we can't hit a pipe. So the first thing that we need to check is, are we horizontally, are we at the same level as the pipe? So are we at the same position of the pipe? So we're going to check if our bird is at the same X position as the pipe, or if our bird is also at the same X position as the pipe plus its width. So somewhere between that. So from the X position, which is this part, till the X position plus the width. So that's our first check that we need. Only then something can happen, because otherwise we can't really hurt ourselves here because the pipe's nowhere inside. So that's the first thing that we need to check. And then the second thing we need to check is basically do two checks. One is if we are in this top part, and one is we're in this bottom part, and then we hit the pipe, then we're game over. So this part, what we can do is we can check our y value, and we can check if our y value is between 0 and the top of this pipe. Then we are hitting this top part. For the bottom part, what we need to do is we need to check if our y value, again, is between this part, which is the pipe bottom, but remember, we don't actually have that. Instead, we have pipe top plus the pipe gap. Between the bottom and basically the end of the screen. If we're somewhere there, then we're also hitting this bottom part. Does that make sense? So first we need to check if we're in the X position, and then we're going to check for this top part, and we're going to check for the bottom part. So let's try. So this is our first check. If the bird eye is higher than the height, then that means that we're off screen and the game is over. Second check, and that's this one. If our bird X is larger or equal to pipe X, and remember, it's not good enough to just check this part, because we can also be just way past the pipe, and in that case, it doesn't really make sense to check. So here we also have to check if the bird X is smaller or equal than the pipe X plus the pipe width. So this is like the left side of the pipe. So we have to check if we're bigger than the left side of the pipe. And we have to check if we're smaller or equal to the right side of the pipe. Right? So we have these two edges of the pipe, and only in that small segment can we actually hit something. It's an important segment, but that's the only way that we can hit the pipe. Otherwise, there's nothing that can happen. And then we're going to do these two checks. So first for the top part. So if our bird Y is, how are we going to do that? Let's cheat a little bit. Yeah. So we don't actually have to check for 0. Instead, what we need to do is here for this part. So this is our pipe top. We're going to check if our bird Y is smaller than our pipe top, right? If we are smaller than pipe top, that means that we're somewhere in this region from this part to this part, right? So we don't want that, because then we're hitting our pipe. Remember, our bird is now, we've now verified that our bird is somewhere in X, somewhere in this region. So we know that we really have to make sure that we're not in this part or in this part. So the first part that we need to check is this part. So our bird Y can't be smaller than pipe top, because if that happens, the game is over. And the other place where the bird can't be, so bird Y, can also not be larger than this part. Remember, we don't really have a name for that, but instead we have pipe top plus pipe gap. Then we're in this bottom part, and then also the game is over. So let's try it. So we're going to play our game now. We don't have any scoring yet, but now if we hit this bottom part, it's game over. And if we try to hit the top part, then the game is also over. Try to verify that that's also happening in your case. Is this working? No? I said it's not working. Ah ja, maar je game over is gelijk aan het. Als je dat doet, dan gaat het gelijk. Ja, en ik probeer het nog eens door te krijgen, dat is niet natuurlijk. Ja. Dat is fijn. Ja, maar nu nog sprongen. Ben het voor jullie?
Maar je kunt wel.
Ja. Nee, deze pas?
Ja, dus dat je niet alleen deze gaat.
Ja. Omdat we checken of dat het word hier is en tot hier. Ja.
Oei. Super kleine
Ja, je kunt dat ook doen als ze kleiner en kleiner worden. Ja. En nu is het tof, Michel, als je naar boven gaat, naar die setting, dan nog heel lang. Dus de parameters van je spel, als je een word 4x groter maakt in plaats van 2, dat is de snelheid waarmee je vogel vliegt, een x, als je die verhoogt naar 5. Ja. Maar je nog redelijk vlot. Ja, een klein. Misschien ben ik ook wat te groot. Het is te makkelijk. Ja. Elke keer als je door de pipe gaat, dan verhoogt de snelheid dat je nog doen. All right, now it's time for score, right? Because now we can play the game, but we don't have any score kept yet. So we want to know when we're actually doing the right thing. Look at me, Kato. Oh, yeah. So here we're going to keep score at the very top. And that's going to be set to 0. And we're also going to keep high score immediately and also set that to 0. So the idea is the score is the score of this game, and the high score is a score in the whole session. So the top score that we have. Right, and we've both set them to 0. In reset game, here at the very end of reset game, we also going to set the score to 0 already. We don't want to reset the high score, that just keeps the same, but whenever we reset the game, of course, our score resets back to 0, so that makes sense. And then we're going to draw those. So we're drawing the bird, we're drawing the pipe, and here we can also draw the score. So we're going to say draw score. Now let's see, we're going to say fill black. And the score is just a piece of text with the word score, semicolon, we add a space, and then we say plus the score. So this is a piece of text, score. We add a space, so we have a space between that and the score itself, and then we plus the score, so that means that we get a string, a piece of text with score, semicolon, and then 12 or something. And where do we put it? Well, I want this score to appear at the corner, so here in the top, and I want the high score to appear here. So for our score to appear there, I want to set the X value to maybe 5 and the Y value to 20 or something. I don't know. And you'll see this is initially is very small, and then it becomes bigger when we have game over. And this is an issue with p5, where we are going to set our text value here, or text size, and our text align, and that's going to stay there for forever, basically, until we reset it. So here, when we draw our score, we probably want to set our text size here to 12, and we also want to set our text align to left. So it just keeps staying there. Now, of course, it doesn't update yet. We still have to do that part. But we have it there. And then also we are going to do the high score. So here we're going to say text high score plus high score. The Y value is the same, but the X value, we want to do the height minus 5
or sorry, the width minus 5, and y value of 20. But now it's sort of off screen here, so we don't really want that. So here we're going to use text align right to make sure that it aligns right. So this value here, this width minus 5, is now interpreted as the end of the text, not the beginning of the text. So now we have score here and high score there. Nice. And now we sort of have to think. So when do we actually score a point in this game? When would it make sense to score a point? Yeah, so if you pass the pipe. So how do we know if we pass the pipe? So when are we cross the pipe? We have all these checks here. When we're inside of a pipe, maybe we can reuse this, but when do we know that we are actually, we finished this, we just passed the pipe? Met die score, dat is dit stukje. Ah ja, en dan van boven moeten hier scoren op 0, high score, ja, gewoon let high score. Op 0 zetten en dan in reset games staat terug score op 0. So this is quite tricky. I've been trying with this, but I want to show you one approach that we can take. So here what we can do is we can say, well, if we're inside of a pipe, so that sort of makes sense. If we're inside of a pipe, then it's game over. If we are at the top part, it's game over at the bottom part. But if we are not at the top part, not at the bottom part, we're actually just past the pipe. So this makes sense, right? So in the other case, then maybe we can add to the score. So here what we can do is we can put these together. We can say else if, so if the bird is here, then it's game over. Else if the bird is here, then it's game over. Else, so in this case, we are past the pipe. So inside the gap. Now we can say score plus equals 1. Would that work? I don't know, let's try. So remember, this first check checks if we are in the top segment of the pipe. This segment checks if we're in the bottom segment of the pipe. Again, not good because then we are hitting the pipe. And else we're right across the gap, so we can increase the score. Let's try this. And so yeah, I get a score. The only problem is I get lots of points every time I pass the pipe, at least if I can do it. Because this doesn't happen for one frame, it happens for a couple of frames. So whenever we are crossing the pipe, we have a couple of frames where we actually are way through this pipe, right? So this is probably not ideal. And this is, again, this is kind of tricky. So the way that I solve this is I looked at if I'm right at this pipe. So if I wasn't in the pipe the previous frame and I'm now in the pipe, then it's fine. And so again, this is kind of tricky. Ja, ik ga eerst eens even laten doen dat dit werkt. So what needs to happen now, just to make sure that you're right, is you have a score at the top, you have a high score at the other part, they're rendered, and then if you cross the pipe, you see that the score increases. That should work now. And if it doesn't, you have to ask me. And so what I changed here is before we had this, what I changed here is I put these two, so this part and this part together with an else if. So the else if basically checks, well, if this is not true, maybe this part is true. And the reason why we do this is because we can do an else statement, and this else statement is in the other case. So if we didn't hit the top part, and if we didn't hit the bottom part, then we must have gone inside of the gap. Ja? Nee?
Ja, mijn tekst, mijn focus van anders. Dus ik kon even niet zien waar je iets aan veranderd was. Dus
Ah ja. Dus hier, drawing. Dit
ja,
is,
dat stond bij mij nog naar onder.
ah ja. Dit is scoring en winning. Ik ga er zo aan.
Ja, dat is- Maar hier stond hier, dus ja, ik had het helemaal
Maar dan niet de en dan dat is twee de eerste is nu zo verlopen en de tweede is dat is niet de quarantaine. Nee. Maar maar de tweede wordt en dan na die als iets meer alles dus op mijn de reden waarom ik dat zo heb gedaan is omdat als je de eerste conditie checkt of dat je van boven zit en de tweede checkt dat je van onder zit en dan als er geen van beide laat is, gaat je naar de first screen.
Yeah. So maybe this part is not clear yet what this means. So this if else if part, this is new, I think. But it's kind of,
You can show the alternative because in the first script we do the else condition.
mhm.
You can also do the or maybe the
Ah yeah. Yeah. So what you can do here, yeah, maybe it's too complex, but you can also use or here for, so you can check if the bird eye is smaller than pi top. So if we're hitting the top segment, or, and then we take this condition, if we are hitting the bottom segment, then in both cases it's game over. It's kind of what you prefer. Maybe this is already a bit too complex if you're reading it in one sentence. So here it's maybe easier to comment. Bird segment. Then here this is bird hit the bottom segment. What's really important with this if, the way that it's structured now, is that it can only do one thing. So it's either the first thing or the second thing or the last thing, but it can't do two at the same time. That's the main reason why we put everything in this if and else if statement. So it has to pick between one of these three. Either we hit the top one or we hit the bottom one, or we don't hit any of them and then we're in else. So it means we're in the gap, which means we're basically in the right position, because then you're correct here.
When they are like linked together, it's not like when you have two different if statements that run separately. And you can see it in line 89 and 90, you see the bracket before the word. And that means that it's a continuation of the previous one.
Yeah, so this whole thing is one block, basically. It's like a ambtenaar really verifying, like you can have one of these three categories and there's no other categories.
The second agency. Second three options, you have A, B,
Yeah, and in this case, this is like the how do you say it, fallback condition or something, where it's just all the rest. Everybody else gets grouped in this segment. But this is actually the segment where we're inside of the gap. So this is the good part. We want to be here. Okay, can you verify in your code that this is working? Again, we don't have one point, but we have multiple points when we go through the pipe, because every time we draw inside of the pipe, we get an extra point. So there's lots of points that to be made. Dat is de bedoeling. Ja, hij laat dat staan. Maar hier in reset game heb ik score op 0 gezet. Ja, Eline? Nee.
Hier zou er ook game over moeten hebben, hè?
Ja, dan wel, maar als ik snel naar boven ga, helemaal naar boven.
Erover? Nee, dat zou ook niet mogen.
Ah ja, dat is een thema. Ah ja, dat is. Dus als het de tijd aan de dichte zijkant, dan is het die open, maar in het begin kan je zo over de bovenkant van het scherm praten.
Ja, hier.
Ja.
Ja. Boing. Ja, dat kun je ook doen. Hè? So you can also say if bird I bigger than height or bird I y smaller than 0, for example. So in this case, the moment you go up, and you go outside of the screen, you're game over. I don't really like this because for me it's fine. Like you can't pass a pipe anyway that way. So it's kind of fine that you can go a bit higher than the screen. You always fall back down because there's gravity, right?
I thought there was something wrong.
No, but there's no way to cheat that way in a sense because you can't go over the pipe. The pipe goes infinitely high, basically. I hope, I think. Yeah, so that doesn't work. Okay. Kato, lukt het?
Ja, zo de mijn jak die blijft zich klein, ook al is het niet groot.
Maar je hebt twee plekken waar je die moet resetten. Hè?
Ja, dat
Dus hier, ja, in reset game doe je dat. En dan hier, als je de pipe verplaatst, dan moet je dat doen. In movement. Dus ik heb dat nu, I've labeled these sections. So I have a section movement, which is all of this code, which only happens when we're playing. So if playing, that's all of that code inside of this condition. Then I have drawing code, which draws the bird, the pipe, the score. And then I have the scoring and winning part, which is this part with the game over thing.
Yeah.
Yeah, so I think the part you missed is this one here in movement. So you move the pipe, and if it's off screen, so the pipe is smaller, pipe plus the width is smaller than 0, then you reset it back, and then you set a new top value and new gap value. If you don't do this, you always get the same pipe, right? And this is the first one in reset game. Wat zeg je? Nee. Ja, bij reset game staat de score nog niet. Dat heb ik nog toegevoegd. Ja. En dat klinkt ook logisch, hè? So it sounds logical. If you do a reset game, then the score resets to 0.
En dan heb ik nog zo een probleem met dat mijn game over en set it to a big font, but when you include then my high score and my score also becomes.
Yeah. So here in draw score, I just reset everything. So I said text size, text align, and then here also text align. Because if you don't do that, then the moment that the text size increases, then you get a big font. So I have fill, text size, text align to make sure that everything's nicely. Yeah, it's kind of annoying that it doesn't reset at every frame, but I kind of understand it because that also becomes annoying in other cases. Lukt het, Kato? Ga ik verder? If you want to make the game a bit more challenging, in reset game, you can set the bird Vx, which is the speed of the bird, to a higher value. So that's going to make the bird go faster, and then the game becomes much more challenging. Ah. Okay, maybe too challenging.
Okay, als ik dan terug heb, het is gewoon omdat je die over, dan hebben we die over stond, dan is dan ook een high score en low score groter worden, dus dan zou ik
Okay. For the rest, there's one tiny change that we can already make, which is to keep the high score. And again, the scoring itself is not correct, but the high score is maybe not so difficult to do. So if we are game over, what we need to do is to set playing to false. And also here, we're going to set the high score, but only if the score is bigger than high score. So here we say, if score is bigger than high score, then the new high score becomes a score, right? So this sort of reads logical, right? So if the score is bigger than a high score, then we have a new high score. So the high score is set to the current score. And that means that we can now play the game, and then it's going to keep that score. So now it's 15, our high score is 15. And now if we do better the next time, then we can increase our high score. So now it's 34. But we're still, this part is still tricky, right? Because we are increasing our score every frame, but it's not really the way that we want to do it. And there's a couple of things that we can fix, but the easiest thing maybe, or the easiest thing that I found, is to check if we just pass the gap, because this is the important part. We need to cross the gap, but only check if that happens once. And the way that we can do that is because our pipe, every frame, it moves with the speed of the birds, is this Vx. We can verify that in our previous frame, we were not in the pipe yet, but now we are. So if bird X minus the speed of the bird, so minus Vx, so that means what is the previous, where was the bird before? If that was smaller than the pipe X, ends, well, not end. Basically, we're done, I think. Yeah, so that's it. I'll show it to you. So basically, we want this code. So we check what the previous value of the bird is. Again, that's not really correct because the bird's not moving, but whatever. This bird Vx is the speed of the birds. Then, and that was smaller than the pipe X, then we increase the score by 1. So this basically checks if the previous frame we were not in the pipe yet, but now we are. We know that we are because we only go inside of this code when we are. Then we increase the score by 1. So instead of doing it every time, we just check if we didn't do it the last time yet. Now we increase the score. And that's basically the whole game. So now we can play. We only get 1 point per frame. You can, again, increase the speed, the Vx, if you want it to be faster. Echt? Je kunt maar tot 5 scoren, dat is wel grappig. Of je zegt gewoon niet goed genoeg.
Instead of what you did, just do bird X equals the pipe X.
Ja, maar dan krijg je dus het probleem dat omdat je Vx, dat je dat niet increase met 1 pixel elke keer, dat je dus dat niet exact hetzelfde kan zijn. Dit, hè?
Ja, of 2.
Dus nu werkt dat, omdat dat gehele getallen zijn, maar als dit 5 is bijvoorbeeld, dan kom je in de problemen. Dan gaat dat soms werken en soms niet, denk ik.
Waar is dat?
But they always intersect. There's always a point where first x and 5x will be.
Exactly the same? No, not necessarily, because if we move faster, we can actually go, in the next frame, we go past the pipe with one or two pixels. So the easiest solution, which makes sense, is this one. If the bird x is equal to the pipe x, so our bird is exactly at the same position of the pipe, then we go to the next frame. But that doesn't always work. And that depends on the speed. If we're moving really fast, then it could be that our bird jumps every time, jumps a couple of pixels, and it doesn't hit the exact spot where it hits the beginning of the pipe. And in that case, we don't actually never get to this condition, so we don't get a point. So the way that we do it here is we are going to check if on the previous frame we weren't in the pipe yet, and on this frame we are. The reason why we know that we are in the pipe is because we are in this condition. So this only happens if we're now on the same horizontal line, so somewhere inside of the pipe, then only all of this code happens. And this one checks if the bird x is smaller than, or bird vx is the speed of the bird. So this would be like the previous position of the bird. If the previous position of the bird is smaller than pipe x, it means that our previous time that we went in this code, the previous time we went in draw, we weren't in the frame yet. So this can only happen once for every pipe, because there's only one time where we weren't in the frame yet, and now we are. That only happens once. So then we can do this, we can add a point to the score. This is again tricky, and it took me a while to figure this out as well. So it's fine if you don't understand this part yet. This is, for me, the most tricky part. But I hope the rest is a bit clear. Again, this seems like a silly example to do a game, but a game has all of these aspects that you need in kind of creative coding effort as well, which means that you need conditions, you probably want interaction, you want to draw something on screen. There's a couple of variables that you need to keep, some state that you want to do, maybe something that resets the project at some point where you say, well, I've run it for 5 minutes, or something happens and I'm resetting it. So all of these are things that you probably want in your creative coding efforts as well. So that's why we wanted to show you a little bit of a bigger example than just these small examples, which make sense, but they're not always so representative for what we're trying to do.
Yeah, mine is still a question.
Okay.
Sometimes I do over when I'm in the gap, but sometimes not, and my gap is still sometimes very, very small.
Wacht, ik kan komen zien. Hè?
And then the position of my high scores, my high score and my score, it's also a bit weird.
Yeah, there's all kinds of tricks that you can do as well. Yeah, so there's all kind of funny things that you can do by adding like one line. You can, for example, in this case, we just make the gap itself move every frame. So it's using a sine function to basically make the gap bigger and smaller every frame. Yeah, it's not really useful, but it's kind of fun to play around with. It makes game very, very hard. Maar ik heb ook eens. Ja, laten we eens beginnen.
Maar ik zal even.
Misschien is dat wel wat klein. Ja. Ja, de teksten is precies.
En ook ja, die gap is soms nog altijd super klein, zodat ik wel hier was in. Dus ik snap niet waarom dat nog steeds zo klein is. En dan, omdat ik die grote greep over had, dan heb ik die high score en de low score hier herhaald wanneer dat greep over is. Naar die positie die nog plaatst. Kun je waarom dat staat bij de interregio? Dat is mooi.
Ja, ik heb nog belangrijk.
Ja, ik zou hier het is al lang op zitten zetten.
Ja, dat is hier misschien zelfs weer en hier rechts.
Maar waarom staat alles daarin? Dat snap ik niet.
Ja,
en dat sport die
ja, ik weet niet, deze komt omdat die gewoon gewoon groot worden.
ja, dat zou ik wel uit.
Want dit,
Nee, dus een game over moet in, maar dus die score en high score moet niet bij game over.
ja, maar dan had ik het probleem dat mijn scores ook gigantisch werden.
Ja,
de eerste
dan ga je daar oplossen. Die krijg ik gescoord, dus ook wel.
en dit is gesynct, ja.
Ja, het is nog eens. Ja, en dan bovenaan heb je het scores. En daar, ja, dat is deze. Ja, en daar moet dus ook veel black, daaronder moeten onderdeel veel black moeten zeggen tekst online, dus waar op die scores staan. Ja, dus de scores staan links uitgelijnd en de high scores staan rechts uitgelijnd.
Ah ja, natuurlijk.
En de tekst size staat 12. Het is wel belangrijk dat als je zo werk van het werk doet, dat je dan niet direct met code moet shiften of zo. Dat je echt even nadenkt van, wat komt er in plaats van zo een reflexie, maar gewoon gaat er ergens anders zitten, wat dat is nog los.
Nee, maar ik dacht van anders dat dat altijd lukt, dan herhaal ik echt gewoon nog iets daaronder, dat is zeker van
Ja.
zo groot moet zijn. Maar dan had je gezegd dat je daar in die reset game best in serieus.
Ja, ken je dat niet? Nee,
Ja.
nee, dat doe ik. Dus dat gewoon bij draw scores, dat gewoon tekst staat. Dus voordat je niet betekent, zet ik gewoon alles in. Ik vind het ook handig omdat het allemaal bij staat. Dus je ziet van, ah ja, voor mijn sport.
Ja, dus
Nu is die game
ja.
over tot alles.
Maar ja, dus ik wou even, dus dat aan, ik kan dat niet groot, dus dat is een probleem.
Ja, ja. Dat wil ik niet. Dus bij draw score, dat
Maar
is...
die game over is ook niet groot.
Ja. Dus bij waar je score tekent, zit er gewoon een tekst thuis.
Dat is wel echt wat. Ja.
Dus je hebt die tekst online. Nee. Dus je hebt je film, daar zit je tekst in. En dan als een game over wordt betekent, dan zit de tekstsize van game over.
Nu weet ik echt niet wat er allemaal
Dit is ook raar, want je hebt hier width 5 en 20. Je moet maar 3 parameters hebben. Dus je tekst zelf. En dan je x en y. En je x-positie moet als width, voor width min 5 of zo. Dan is dat niet te. En dan je y-positie is een beetje lager, omdat je op de basislevel zit. Dus een beetje. Ja, die komt die mooi. Maar die kleine heb is niet. Maybe the link is false if you want. Link is false if you want. You could have asked it. Instead of not.
In een beetje sneller.
There is a game that allemaal parameters die het spel sneller gaat. De bird phoenix is de snelheid van de vogel die x. Oh ja.
Ja, echt waar.
En die tekent toch juist een indicator. Dus je tekent deze puntjes. Die deze stijgen door ze te zetten misschien. Dat je deze punten tekenen. Dus van 0 tot aan waar je dat klopt negatief tot aan waar je top tekenen. Dus de gap is eigenlijk echt de ruimte tussen de twee. Dus het bovenste stukje tekenen tussen 0 en de top, dus hetgeen dat je net getekend tot hier.
Ja.
En dan voor dat tweede stuk te tekenen, de eindpositie, daarvan te weten, pak je de top plus de gap en dan kom ik hier zo.
Ja.
Dus de gap is wel juist, maar je tekent het fout.
Ja.
Hmm.
Oké.
En dan kun je ook, want soms staat het heel hoog, dus dat je hier bij de top een random, die laat beginnen met 0, maar dat 30, 50. Dus dat je hier ook iets knal naar boven. Naar boven is. En ik vraag me altijd de tweede met die doen. Dus de allereerste vraag doen. Dus die bij top hier staat de random. Ja, slecht geen koud. Oké, je bent carrière omzetten.
Het is aan u, maar dat heeft even tijd gekost. It took some time. Ja. Dat is ook lang, hè? 120. Wat dan? Ja, we gaan switchen. Absoluut. So I'm going to stop sharing. I'll keep recording. And then you can share your screen. And oh yeah, are you on Zoom? Heb je een link van Zoom? Perfect.
Okay, so Marijke, if you cannot follow, I am taking the lead now. So hello.
And I'm going to share screen again.
And oh yeah, I need to share my screen with you. Yeah, this is good. I will try to keep the chat in my view, but I might lose it. I don't know if I get notifications. Okay. Okay, so we have seen Flappy Bird, and now we're going to take a turn and do another exercise. I am like Frederick, I'm very messy and chaotic, so please ask questions. Also, I'm not that experienced as him, so I'm gonna look at codes often. But the final result is this. So we're gonna make an analog clock, and we're gonna use some functions from p5 that are built in that will help us. We will see new stuff, so get ready. And if you're wondering why I have High School Musical here, is because I have this idea where when you click on it, it will tell you that it's not summertime yet, because that's like the song. If you haven't watched High School Musical, you will not understand the joke, but it's also not there yet, so it's just a clock for now. But the idea is also to have sound in the end to say it's, yeah, anyway, that's not important. Hopefully you have been following along and you have your files. I have this very messy thing, and what I'm going to do is just take the Flappy Bird example, which mine is completely different, but it doesn't really matter. So I can just copy paste it. So Control C, Control V, or Command C, Command V. Wait, what did I do? Doesn't work. Okay, so I'm gonna click on it. I'm gonna do Command C, Command V, and then I get a copy, and I will rename it to clock. Can I do that? Yes. Yeah, I already have a clock. So I'm gonna call it clock 2, but you can do whatever. I have a lot of files here, which is also not ideal. I'm gonna remove some files. Ding, ding, ding. I'm also going into my index.html. I'm gonna make sure that I have linked the right one. So you should have something that looks like this. And my file is called sketch.js, but maybe you have been working with main.js, I'm not sure. It can be any name. And then I have a folder here, but just ignore that. I'm gonna delete it. It's for another example. So this is the structure. Hopefully you have it. For the script tag, I think you have something different.
Yeah, unpackage.
Yeah, so
It's the same thing, yeah.
Instead of this, you have
That's okay.
something else, but this is what I have. So if you have copied the previous example, then it should be correct. Okay, so inside my sketch.js, just gonna remove everything. And I think I have written something somewhere. Yes, I have a thing. So we have a structure of what we're going to do, because a clock seems very easy, but it comes with a lot of stuff that we need to figure out. But the first step is to actually get the time, the current time that we see on our computers. And if you go to p5, like this. And if I look time, haven't done this before, so I don't know what I'll get.
Yeah.
Sorry, I had to mute my phone. Then you should see something, but this is not what I was. Is that me? That's not me. Playing music.
Voila, that happens if you open the time page.
Is that? No. Wat? Ik ben kaart in de war. Okay. Maybe if I search. Waar komt het geluid vandaan?
Is er een video kunnen staan? Bedtime.
I have no idea.
Komt uit een telefoon.
Nee, dat is echt van deze pagina's, hè?
Ja, dat weet ik maar.
Oh.
Dat is dat.
Okay. This is clearly.
Je moet het gewoon in reference gaan zien. Dus aan de zijkant reference en dan heb je time and date.
Ja.
In de pagina.
Nee, gewoon reference klikken daar. Ja.
Oké, zo. Waar staat dat nu? Ik zie dat niet.
Nee, dat is wel verwarrend. En dan time and date staat er ergens. Yeah, so you see there's lots of commands that you can execute in p5. Nee, nog. Go.
Ik should have done this before. Waar staat dat? Ik zie dat echt niet.
Nog. Ja, beetje lang.
Oké, I don't know. Nee, ik zie het echt niet.
Hit IO en dan de time and date. Ja, daar.
Okay, oh my God. Okay, so we have it. Inside the references, there is this part where you see built-in functions that will give you the current day, the current hour, the current minute, the milliseconds, month, second, year. And if I click on the hour, for instance, you can see that it is actually super, super easy to get the hour. So that's something that we can do now to check. So I'm going into my Visual Studio Code. Should I put it in light mode?
Ja.
Don't know how.
Command palette en een team. Zo doe ik dat.
Wat?
Bij Go, command palette. Of view, sorry. Command palette. En dan kun je team typen. Ja.
So we're just gonna do the usual, which is our setup function. And we create our canvas in here. We do 400 by 400 pixels. And for now, I'm just gonna leave it like this. And then we create our function draw. And in here, well, actually before doing anything, before any of the functions, I'm gonna declare some variables, and I'm gonna declare variables for the hour, the minutes, and the seconds. So I'm gonna just type them out completely, but feel free to use any abbreviations that you would like. Minutes. Can you also see? Oh yeah, you can also see that. Minutes, seconds, and also milliseconds, just to be fancy, but you don't have to. I'm gonna call it millis. Because
Ja,
that's
problemen met je hour noemt, want hour bestaat al. Je moet dat hours noemen.
okay. Call everything by its plural name, because otherwise you might have issues, because some things are already used. Like if I were to say hour instead of hours, it will get confused because this is already called hour, for example. So it will be like, oh, what do you mean actually? So hours it is. And in here, I'm just gonna say hours, and I'm gonna call the function hour. And that should give me the current hour. I'm going to,
Ja, oké.
not like this, sorry, this should be a function. Like this. So this is a function that I'm calling to get the hour, and this is the variable that I just declared. So I'm putting the hour inside of my variable. I'm going to repeat this for all of my other variables. So minutes equals minutes, maybe, I think. So I'm just gonna check. Yeah, so it's always singular. And then for milliseconds, it's just the abbreviation millis, which means that I might not be able to use this. So I'm gonna change it to milliseconds. So just do this very quickly. Minutes, seconds equals seconds. And then milliseconds equals millis, like this. And for me to be able to see this on the screen, I need to put it inside something. So there are different ways in which you can construct the variable that is composed by multiple variables. No, wait, there are different ways in which you can compose a string that is composed by different variables. One of them is called template literals, and the other one is just a string plus a variable plus, and so on. So let's create it. Let's maybe digital time equals the hours that I just declared plus And then in between quotation marks, I will add my colon. And then I do plus again, and I add my minutes. And I do plus again, and then quotation marks. And I just repeat the same thing over and over. Let's do them all quickly. It's kind of tedious to type, but this is good. Plus, quotation marks, colon, plus, milliseconds. So this is like the lengthy way to do it. And it's also kind of like the first way you learn to compose a variable that is composed with other variables. But the other one, which in my opinion is better, though that's a very bold assumption, is to do the same but with literals. And it will do the same, but it's just a different way of typing it. And we do that by using backticks, which is like the accent symbol, which looks like this. I'm not sure if you all will be able to find it on your keyboard. For me, it's next to the shift. I have a QWERTY, so I don't know. Otherwise, you can just Google it. And then instead of using the plus signs the whole time, what I can do is just, if I want to use a variable, I use the $sign and then the brackets. And whatever I put inside these brackets will be my variable, which is hours. And then instead of going plus blah, 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 plus blah, 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 I can just do my colon because it will take that as a string. And then just repeat the process with minutes, seconds, and milliseconds. So now I have it, and just see the result quickly. I'm just going to log it in my console log. So I'm just going to console.log digital time, and I should be able to see something. So let's see. Ja, inderdaad. En ik heb daar geen link naar. Just a
Dat
second.
is ook niet dus. Nee? Misschien moeten we gewoon die index.html open doen met live server. Dus op index.html klikken. En dan in VS Code.
Maar dat is al open, hè?
Nee, de indexpagina open doen. Index. En dan
Ja, inderdaad.
doen en dan open het live server.
Okay, so I see nothing, and that is normal. But if I open my console, I can see that my time is logging constantly on every frame. So the time gets updated every time the draw function loops. Does this make sense? Questions?
Ja, ik denk als je backticks aan het zoeken.
Ah ja, maar je moet dat niet per se met die backticks doen als je dat niet meteen vindt. Dit is ook goed. It's the same but different. And then if I
kiezen. So you have to choose either you do the one or the other. Otherwise, you get an error. If you say let digital time equals and then below let digital time equals, it's going to claim that you can't define it twice.
yes, and that's why I commented one of them out. So if I would to do this, it would get confused. So it says that it's a redeclaration, so it has been previously declared at line 15. So if you see here, 15, I have my digital time, and on line 17, I have one. It is not ideal. I'm gonna add a background because I don't have that. Background like this. I'm gonna give it a color of black, and in my setup I will, maybe not, yes, I will do my text align to the center, which we have used before, and I'm going to just display my time inside of a text. thing. So text we have used before. It's gonna take the digital time. My position will be width divided by 2, height divided by 2. And the text color, is it text fill or home fill? Just gonna make it white and it should show on the screen. Okay, so it shows and it just keeps updating. It's super pixelated because I'm zoomed in. But if I make the text bigger, text size 5, yes, then you see the time. There are some weird issues. For example, on the minutes, you only see 1 0, but it should be 0 0. But that's not something we're gonna cover right now because actually we don't need the digital clock. I'm just doing this to show you how to get the values and how they are displayed. We're going to use these values though for our analog clock. So you can choose to keep this or remove it. I'm going to delete it because I don't need it, I think. So should I go back or has everyone?
Of zet even in commentaar. Iedereen was dan nog zo.
Ja, dus ik ga even zo zetten. But be mindful that it can only be this or this. So never both. Command slash?
Ja.
Als je selecteert en je doet command slash.
Je moet eens gaan zien in het edit-menu van boven staat er toggle line comment. Dat is degene die je wilt. En
Dat is wat je bedoelt, sorry.
shift slash?
Command K, command C.
Ja, dat is wel kei handig.
Wat?
Command K, command C.
Ja,
Om een lijn in commentaar te zetten. Ah ja, oké.
nou, die command C, command K,
Oké.
Maar bij mij is dat niet.
Ah ja, inderdaad.
Die combination is not a command. Both.
En probeer eens command shift slash. Dat gaat niet.
command shift.
Ja, dat is makkelijker, denk ik, dan zo Ctrl-Alt.
Ja.
Ah ja.
Yeah. Can I continue?
Yeah.
Okay. I'm just gonna remove this because it's just gonna get in the way for me. So the way we're going to do this is now we have our time, but we have to actually translate it into an analog version. And with that, I mean that an analog clock is a circle, right? And as you can see here, we have a clock as an example, and you see 12 numbers, for example, instead of 24. So that's something that we also have to take into account. And what we are going to do is translate hour to an angle degree so that we can draw our circle. And there is some math for that, which is not super difficult because I was able to understand. So if I can do it, you can do it. So now we have our hour, but we have to do some calculations. And the way we do this is by first dividing our hour in the total number of hours, which in this case will be 12. Right, quickly check.
Ja, jij doet dat anders. Ik vind dit veel logischer wat je nu doet. Gedeeld door 12 maal 360.
Ja?
Ja. Maar hier doen we maal 360 gedeeld door 12.
Ja. Dus ik ga het gewoon zo doen. Dus, so we divide the number by 12 and then to get the angle degree, we should also multiply this by 360. So like this. And this will give us the angle number.
Mm-hmm.
And then
This is like the rule of 3, right? So you take the hour, you divide it by the amount of hours that you can have, which is 12. In this case, sort of 24, but we'll ignore that. Which means that you get a value between 0 and 1, and then you multiply the value between 0 and 1 to a value between 0 and 360, which is the whole range of the clock.
And then we actually have to repeat this kind of calculation throughout all the other numbers. For the minutes, it's not going to be 12, but it's going to be 60, because for you to be able to go full circle, you have to count 60 seconds. So
Minutes.
60 seconds, yeah, 60 minutes, sorry, is like one full circle. So that's why we make the division by 60, and then we also multiply by 360. For the seconds, it's going to be exactly the same, because we do have a total of 60 seconds in a full circle. And then for the milliseconds, I had to look this up, but you have a total of 1000 milliseconds for you to be able to go full circle. And then we also multiply by 360. There is one extra step that we have to do, but I'm going to skip it for now, and I will show you later. So what will be the next step? Now we have our angles. So we have translated our time into the degree. And now what we need to do is to draw our lines. And before drawing the lines, I'm just going to create a circle that will visualize our clock. So draw clock circle. And I want the circle to start from the center. So I'm going to use the circle method function that is built in, that will take the parameters x, y with height, I think, or maybe diameter, not sure.
Diameter, ja. Dat kun je inderdaad opzoeken.
p5 circle. So if you're not sure what the parameters are, you can always look them up. Oh. So there is circle and there is ellipse. And the difference is that the circle only takes 3 parameters, which means that it will always be a circle, but with the ellipse, you have like 2 values to make it an elongated circle, which is an ellipse. So for and y, I'm just going to do the width divided by 2 and the height divided by 2. And I'm just going to choose a random number, maybe 100. I'm going to give it a stroke. No, like this. I don't know if this will work.
Dat is string. Ja,
Within a string. So it has to be inside a string. You can do RGB values or whatever, but I find this quicker. That's not it. This one. So you can see our circle with a stroke. It is a bit too small, so I'm going to make it a bit bigger. 200. I'm going to make the stroke a bit bigger as well, so maybe 5. Whoop. Stroke size does not exist. What is it?
line weight of zoiets.
Stroke weight.
Stroke weight.
Yeah, thank you. So stroke weight. And I don't know how to type. So, okay. So now we have a circle. This is our clock. I'm actually also going to get rid of the fill. Can you do no fill? Is that a thing? No. Oh yeah, you can. Okay, that's good. So now we have a circle that starts from the center. Now we should actually make our wijzers in het Engels.
Hands. Clock hands.
Okay, clock hands. So the lines essentially that will represent hour, the minutes, and the seconds. So we're gonna start with the hand for the hour. And for this, let me check my notes. Yes, so we need to use some functions that are new, but let me just draw the line first, and then I'll show you what push and pop does. So first we need to actually move our point of origin, because when we draw something, it will always start from the left,
Top left corner.
top left. So at 0, 0 is where every single object that you draw will start from. So that's like your original X and Y value. But actually, I want my hands to start from the center. So I need to shift that X and Y coordinate to be the center. And Friedrich will do a demonstration, I think. Yeah, so initially you have the X and Y position to be 0, 0. So that point that Friedrich is drawing, but I want to move that to the center. So it needs to be moved there. And there is a built-in function that makes life easier for us. And that's called translate. And that will actually move the point of origin to wherever you would like. And in this instance, we want it to be the center. So it makes sense to say that my X and Y origin will be the width divided by 2 and the height divided by 2. So that will be the center. And it looks like this. So translate is the method. And then here's code always does this stuff. I want my point of origin to go from, let me try and say, the PO to go from 0, 0 to the PO of width divided by 2 and height divided by 2. Okay? The point of origin. Maybe I should. Point of,
It means, so the point of origin is where the computer thinks that 0, 0 is. So now, if we don't do anything, we start up processing the point of origin.
it's always at the top left.
Yeah. If we use translate and use width divided by 2, height divided by 2, and our point of origin is here. Which means if we now draw a line or a shape at 0, 0, it's going to draw it here.
Yeah, that's the native point origin or PO is something that you.
Yeah, that actually doesn't exist. That's not a thing. Yeah, that's why I put it in comments. So it might be kind of confusing. Maybe I shouldn't write it this way, but we'll go with this now, and then I will see how I can make it better.
Ja.
Ja, dat is also de start van die positie, zeg maar. Maar het is nog wat anders.
But the good reasons why we are doing this, because we're not doing this because we want to, but we have to. So the reason why is, in a moment we want to draw a line, right? The clock.
Yes.
But if, that means that we need to rotate. We have to rotate along this angle. And so what p5 is doing is going to rotate along this point of origin. So if we use rotate now to rotate our hand, what's going to happen? So that if we don't do anything, is that it's going to rotate from this, and so our whole canvas will be rotated like this, which is completely.
So I can maybe demonstrate that.
Yeah.
So before doing the translate, we're just gonna draw our line. The stroke will be red again. And the stroke. Wait. No, maybe. Keep it like this. I don't know if I should. Yeah. Anyway, and the line takes the following parameters. So to draw a line, we need to give the coordinates for both points. So the first point and then the second point. And I'm just going to say that the first point should be 0, 0 for now. And then the second point should be at 200 by 200, something like this. So what happens? This happens. So my point has a starting X position of 0, a starting Y position of 0, and then the next point is 200, which is coincidentally also half of my screen. If I want to rotate this, there is a built-in function sorry, yeah, the metaphor. If I want to rotate this, there is a built-in function that's called rotate, and I need to use an angle. And the angle that I will use is the hour, which doesn't make sense because you will see a change every hour. So I'm just going to use seconds to see the results. Well, now it's gone. That's because, yeah, see, now it's here. So now it's moving, but it's moving, and the point of origin from where it's moving is the top left. And I would like to switch that to the middle so that it becomes an actual clock.
So basically, it's doing this, right? It's
Yeah.
Right here. And so by translating, what we do is we take this middle and we put it here. So now we move it goes here instead of this other direction. There's another problem, and this is to rotate and things, so they are remembered.
Mhm. Yes.
So you see that it doesn't actually rotate the way that we want it to. So it has these big jumps.
Yes, but is this clear? So we're doing this and it's actually going backwards, but we're going to fix it. And what Frederick is saying is that our rotation is and translation is being remembered constantly. And what will happen is that if we make our next line, so if we make our milliseconds, for example, in this hand, line 0, 0. Nope. Ja, dat was een kloppen, denk ik. Want dan moet je al.
Yeah. So yeah, it's basically to draw, so from this point, to draw a straight line. And so we think of 0 seconds and 0 milliseconds like this, straight line up. And then rotate is actually going to rotate from this point, it's going to rotate in the position where it has to be, so this first. Right, that's ideally what we want. So we want our next position to start at 0, 0. And then for our y, what we're going to do, our second point, our x still stays at 0, but our y now goes to like minus 100%.
Okay, and now as you can see, this line is also being moved. Like it's also rotating according to the seconds, but I don't want that. I want this to have its own specific rotation. And we can fix this is by introducing the push and pop functions. What that will do is before writing the logic down for one line, I need to start with push so that I can create this kind of like contained logic. And this will indicate like the beginning of my translation and rotation. So it will only be applied to whatever is inside the push and the pop, because the pop is actually the end of this container essentially. And what you will see now is that my second line is being rotated, but my other line is not anymore, and that's because it is outside of the pop. So for every line that we're going to draw, we need a push and pop container. And if you go to P5, there is also a reference push pop, p5.js, where it explains what is happening.
Yeah, so push basically saves everything, so it saves where it was before. So if we save it, it's going to say, okay, you were here at this position with this rotation. Then we do our stuff, we can move our canvas, we can scale it and rotate it. And then if we do push pop, it's like never happened. We just go back to this position.
It's like we enter a sort of room where everything is being rotated in a sense, and then if we do pop, then we get out of it and we just continue with the flow of the code. as it were originally. So it is actually super handy because now we can control the rotation for every hand separately, right? So we should be able to, I mean, with this logic in our heads, we should be able to create all of our hands essentially. So I'm just gonna start with the hour. So in here, I do the translation so that I move my point of origin. I have a rotation, and instead of seconds, I'm going to change it to hours. So that it just stays at 1 hour. And then you will notice that something weird actually happens because now it says that my hour is like 8 p.m.-ish, I think, which is totally not true. And why is that? It's because when we draw a line, it will start drawing it from the top to the bottom, right? So the first coordinate will be the top one, and the second coordinate will always be the bottom one. But with a clock, we actually start at midnight to 12, so it starts upside down, essentially. So what we need to do is to flip everything around so that it starts at the right moment of the day. And to do that, we actually need to go back in here and just add the degree of 180. So it's minus 180.
Er is nog iets belangrijks.
Yes.
Dus je angle mode moet ook op degrees staan, en niet staat er op radians.
And this will make sure that our hands always start at the same point. One other thing to note that we forgot about that inside 5 degrees are handled by radians, which is a mathematical thing that I'm not going to explain, but we can actually change the angle mode to make it easier for ourselves. And I'm doing this in the setup, so I'm adding the angle mode, I'm setting it to degrees. Radians is something that is based on, I think for you to be able to go full circle, you need to do 2 pi or something. It is a math thing. You can look it up later.
I think we talked about it last time, and it was also confusing then.
Yeah, it is confusing. So stick to degrees in the beginning. I think it's more, it's easier to understand in degrees, and then you can step up and do radians. Because when you redo this in radians, it will actually be less code because radians is sort of like something that the computer is more familiar with or something. But anyway, we need to do this the human way for now. And now if I look at this, it still looks weird. So it's not the right time yet.
Check je lijn eens, want die gaat nog altijd van 00 naar 200, 200.
Yeah, so in here, I actually need to change this position to 0 so that it always starts at the same. And now our hour starts at 12 and it is indeed 12. So it is correct. So if it's not pointing to 12, change the X coordinate of the second point in the line. And then I made it 200, but I actually wanted a bit smaller because my circle, the radius of my circle is only 100. So let's go for 90. And by radius, I mean like half of your diameter. I hope you know these things. So you have one circle, and then if you cut it in half, the distance between point A to point B is your diameter. And if you slice that in half, you get the radius, which is half of the diameter. And we had set our circle to be 200 here. So half of it is 90. And that is why I'm getting the right thing. Okay, so we have our hour. Let's do our minutes and hope minutes ends. So I'm just going to repeat the same procedure. I'm just going to do push to get into the zone of minutes. And then I'm going to translate again because the translate has only been moved inside of the previous push, so we have to repeat the same step. So the width divided by 2 and the height divided by 2. Notice how I am very messy. Sometimes I write my semicolons, sometimes not. You should choose one or the other, never do what I'm doing. Also, one thing that I also do constantly is sometimes I use double quotes and single quotes simultaneously. That is also not good.
But it doesn't really matter.
Yeah, it doesn't matter. It does the same, but it's just not the appropriate way to do this thing. So let me just change this.
Heb je in Prettier die de automatisch sorteert?
Ja, dat werkt niet. Nee, ik weet niet waarom. Maar ja, ik let er ook niet echt op. Yeah, so you also have an extension called Prettier that can alert you when doing stuff. And I think maybe the reason why it's not fixing it for me is because I turned it off, because it can be annoying sometimes. Because sometimes it will, if you have like strict Prettier mode, it will check every semicolon, and if you're missing one, then...
Nee, maar dat formateert ook alles. Hè?
Ik
Er
doe
zit
het
alles
ook.
in. Dat is keihandig.
Anyway, Prettier will be the next...
Yeah, next course.
The next course. So we translate our point of origin. We define our stroke color. So I'm going to change it. I'm going to do orange to make a distinction between minutes and hours. And then I'm going to use the rotation. And here I will rotate by the minutes. So I'm going to use the minutes variable inside here. And then I just draw my line, which will always start at 0, 0. And then also another 0, and then let me make it longer than the hours. I don't know how clocks work. Yeah. So let me make this 90, and let me do the hour a bit smaller, 60. Know how that's gonna look. Okay, so we have the minutes. It's looking great. Is everyone here?
Nog een pop op het einde.
Oh yeah, wait, is that a message? Oh, nee, dat ben ik gewoon. Yeah, so do not forget your pop, because if you were to forget this, let me show you maybe. So I'm gonna comment my push and pop out for this too, and let's see what happens. So the first line gets drawn and the second just disappears.
It's because we're again translating, yeah? So we're moving everything again off of the page, which means we're basically off screen.
Yes, so let me just make this translation a bit smaller. So let me just do 50-50. And what will happen is that it moves 50 pixels to the left.
But also it's already rotated, so it's rotated by the hour.
Yeah, because the rotation here, the rotation here does not start at midnight, like here. It starts at midnight plus the previous rotation. So it will take this one as well. And now coincidentally, it is 12. So I think it does like 12 plus 12. Some math happens. Yes, it's actually confusing. So to prevent that, we keep our push and pop in place so that everything is contained in its own container. Room, box, virtual space, it can be anything you would like. Let's just continue and do the same for a second. So at this point, we're just repeating the code, so it's just going to be the same over and over and over again. So again, with the translate, I'm just going to go ahead and copy paste stuff because I'm lazy. So I'm just going to copy the entire thing. And I'm going to change the color to purple. I don't know how that's going to look. And this is seconds, I think. Yeah. So seconds is it's going to be as long as the minutes, but the stroke weight will be thinner. And again, this is just like a stylistic choice. You don't have to do what I'm doing, and I'm just trying to follow Oh, this is cool. Oh yeah, that's because I need to change the minutes to seconds. There you go. And now we have our seconds. Tick tack, tick tack. Or is it TikTok? Anyway, so this is working, and you've also seen that the minutes bar has shifted from 29 to 30, which is great. And then the last one, I'm just going to copy this entirely and call it milliseconds, millis. And then the only thing that I'm changing here is the stroke color. I'm going to do white. And the line will be kind of small, maybe 40. And the rotation is not for the seconds, but for the milliseconds. Whoa, and then some crazy stuff happens. And that is because, let me check, we still need to do some calculations. So,
Ja, millis moeten ook delen. Hè?
ja, heb je dat niet gedeeld door 1000? Oh. What is this?
Dus,
Oh, wait,
Flappy
let me
Bird.
just move this because it's sitting there right.
Nee, daar heb ik nog niks mee gedaan. Maar dat is een ander voorbeeldje. Hè?
Yeah, I was looking on the wrong thing. Oops. So it's not 100, but 1000. That's my mistake. So if you go back up on where we define our milliseconds, I wrote 100, and that's why it's going super fast. It should actually be 1000. So it should do something like this. It will still be fast. One thing to note is that our frame count is 60 frames per second as a standard in P5, but to get a more accurate millisecond count, we can actually up the frames per second so that we can get more of an accurate thing. It will not make a huge difference, but it is recommended. Well, now we actually have our code working, but there is one detail that is actually important. As you see, the clock is divided by 12 and also by 60 parts, but every time you reach like half of your minutes or half of your hour, your hands move like sort of like in between a number. So if it's 9:30, your hour hand will not be exactly at 9, but it will be between 9 and 10, right? It's like the small shift. And there is a calculation for that. What was it again? Let me check. So it is this part where we need to add the seconds to the hour and the minutes. No, the seconds to the minute and the minutes to the hour, so that we can look at how movement going. Is that a bit clear? Because I had a lot kind of troubles understanding that.
For me as well.
But do you know why we're doing this? So it's because we try So it's 2 p.m. So my hand will be like this. But once it hits 2:30, this and so you need to add something to the hour, and that's the minutes. The degree of the minutes, right? And to get that degree, we need to divide the minutes in divided by 60 to get the degree to add to this hour. So to get handle the hour itself, we also need to add the minute divided by 60. So that's the reason why we divide by 60 is because we need the degree to add. And we do the same for the minute, but instead of adding more minutes, we add seconds. Is that a bit clearer?
The way I think about it is that if you're at 230, it's like 2.5. So minutes goes from 0 to 60. If you're at 30 minutes in of the hour, you're at minutes 30 divided by 60, 0.5. So hour 2 plus 0.5 is 2.5. And then we do the multiply by 360, so it becomes a clock. But 2.5 is actually somewhere in between 2 and 3.
So we take that decimal and we add it up to the clock. And I think I should do this. Wait, I'm also going to have issues because I am declaring something and using it before declaring it. So, but I think mathematically speaking, I need to do, I'm gonna put the first division in brackets. And then I will add the seconds in this case, divided by 60. I don't know if this is mathematically correct. I guess we'll see. And then I also need to do the same with the hours. So I'm putting this inside brackets like this, and then doing plus minutes divided by 60. But now I will have problems, so let's debug for a second. And well, it is just working. That's not supposed to happen. That is because, what am I doing wrong? Oh, no, it will work, I think. Or maybe not. Yeah, so you see that when I refresh, something weird happens, and that is because I am using minutes in here before even getting the actual minutes. I was hoping for an error, but I have declared my variable in here, like at the top, and what it is taken here is just like an undefined value as we saw previously, and this will actually just be 0 in this case, but it shouldn't be 0, it should be the actual minutes. And for me to be able to fix this, I just need to shift the order in which I do this. So I'm just gonna take the hours, I'm gonna put them all the way to the bottom, and then I'm gonna do the same with the minutes, and I'm putting it before the hours. You can also put it after. But the main thing to look out for is that you have your seconds first before using them here. And then you have your minutes first before using it here. And I think it should work. Yeah, it's working. So this is a clock. And I'm not sure if I forgot anything. Is that? Maybe I've done something wrong. Just hold. Met wat?
Yeah, maybe it's right. I'm confused.
Well, we can go over this one, which is the same. So this is the same, but it's just done in 2 different steps. So first we get our seconds, our minutes, our hours, and our milliseconds. And at the same time, we're also adding the percentage that we need to get like that half thing going. And then we just do the same where we convert our hours into degrees with these calculations in between brackets. And then we also flip them so that they start at the top and not at the bottom. So these are just 2 different ways of writing it. This is one way, and this is one way. So this is my way, and this is Frederik's way, actually. This is in the way, I'm really sorry. This.
Dat is nog anders. Ja.
Is that
Ja.
the cam? Ik weet niet. The cam.
I think especially initially, if you want to make something, you want to make sure that every step is really, really explicit. So don't try to put all the code in one thing, because it's maybe more confusing. Yeah, well, yeah,
Yeah, so he made two different variables. So fraction here just means that
a fraction is a value between 0 and 1. So
yeah,
in my head,
so you divide your circle into the hours.
yeah. In my head, hour is basically like this, or minutes is basically like this, where it goes from 0 to 60. And it just moves up. The fact that it's round, that it's a clock, is actually has nothing to do with time itself. That's just a representation. So what I do first is make conversion between 0 and 1, which is my fraction. So if I'm half past the hour, I'm here at 0.5. And then I take this value and then I multiply it by 360, so then it becomes an angle. Again, it's the rule of 3, like we saw before, like again, it's also, but then just stretched out and put it into 2 parts. I think the nice part about this is this part allows me to do something else with the code. It doesn't have to be so. For example, you can make something where it's a screen with bars, where every bar is like a height of this is the minutes, and then this is the seconds, is the minutes, this is the hours, and then you have different visualization. Also a nice exercise.
Oh, okay, I don't have access. I just wanted to show you the things you can
Yeah.
do, because it's a very common exercise to do, the clock thing, and it takes some work in your head to be able to shift the hour thing from a circle to just like a diagonal thing. But once you have the fractions from 0 to 1, you can actually do crazy stuff. So it can be maybe a challenge for you to later on try something different, maybe not an analog clock, but just like a very abstract clock. So there is a link, but oh yeah, here it is, I think. So I don't know if you know John Maeda, this person. He's I think he's famous. I mean, I'm not sure. He knows a lot about code, but he has done this thing where he did like 12 clocks for every hour or something. And every time it's the same data, but it's just visualized differently. I don't know if you guys have questions about any confusion that you might have, because it is quite a lot of new stuff. Yes?
Can I see the visual? What?
Oh yeah, of course. Yes.
Because it's still 12 and not like 12 almost 1.
Oh yeah, that's true.
Ja, wel dat die geschiedenis gewoon laten zien.
Maar misschien heb ik, maybe I put a parenthesis in a wrong spot.
No, but it's in between 12 and 1, no? It's not completely.
Ja, dit is echt inderdaad.
Misschien moet dat zo. Wait.
But now, I mean, I did it initially as well, because I took some time yesterday to go through this, and the only way that I could solve it was to split it up into 2 parts. So don't feel bad if you're like, this is way too much multiplying and dividing in brackets. If you feel that this is too much, then it's much better to split it up and to really be explicit about what you're trying to do.
Yeah, so we can actually do it. It's not.
But I think it's working, but because your stroke is like a little bit thicker, so you might see it.
Well, no, it should have a slight angle actually. I don't know where the other one is.
Yeah, that's it. keer afgeschoven voor een tweede criterium en dan is het wel na 2.
Yeah, so it should look like this. It should look like this, but mine doesn't. And maybe it's because indeed I have
Maybe it's better to
I've done too much math at once.
split it out.
So we can try and split it. So let's just create the new, what should I call this? Let's our angle, because now it will become an angle. And then minutes angle, seconds angle, millis angle, hours, minutes, seconds, milliseconds. Okay, so I'm just gonna rewrite this in a way that might be a bit clever. So first we need to get the fraction number, which will be a number between 0 and 1, like so. Just removing all of the parentheses that I wrote. Right? So this is step 1. And then for the hours and the minutes, we need to add like that extra fraction. So I can say plus seconds divided by 60. Is that what it mislooked? Want ja, dat is toch letterlijk wat je hebt.
Okay, so I take
Right.
6 keer een minuut. Een minuut dat er 60 minuten. Dat is een minuut plus de seconds fraction. Samen dat er 60.
Je deelt dan nog eens door 60. Ah, ja.
Dus de seconds fraction is al gedeeld. Dus de dat is 60 op de dat is 1. Is it 1? If you're in half of a minute or half of an hour, for example, we're at 0.5. We want to add that to the hour. So we want 12.5.
So it should be like this, but then just adding a parenthesis.
Yeah.
Right? Does this make sense?
En die seconds moeten ook hier. Yes.
Ja.
So,
Nee. Ja, sorry. Ik heb de neiging om zo.
so all of this code and all of the other examples also on the p5 example site that we did. And there you can also find the source code for all of it, which is similar to what
En hier.
that was done. So in the top, line 9 to line 12, they all become values between 0 and 1. Right? Seconds, minutes, hours, degree. All now values from 0 to 60. They become values between 0 and 1. And afterwards, we take these values and we multiply them by other values, and this is still wrong. So we
Yeah.
multiply by 360.
So in here you just do this. But let me just. So now we have the things. And we need to get the angles. Wait, didn't I declare it before? Oh shit, ik zit op een andere. So I was working on the wrong file again. Yay.
Wacht, nee, want dat is een voorbeeld. Dat is niet. Als we de al kopiëren.
Ja, ik ga dit kopiëren. So I'm just gonna copy this in here. Like so. Which this is kind of redundant because we have it here already. But I'm just gonna comment this out because I have it here declared already. And then you just declare your angles because in here we get the fraction number. So it's a value between 0 and 1. And now we need to convert that value into an angle. And the way we do that is just by saying our angle equals the hours multiplied by 360. And then don't forget that we also need to flip this. So flip the stroke 100 degrees so that it is pointing upwards. Right? So we just do minus 180. And then we just should be able to repeat this for all of them. Minute angle equals minutes multiplied by 360 minus 180. Second angle equals the seconds multiplied by 360 minus 180, and then the milliseconds, the millis angle will be the milliseconds multiplied by 360 minus 180.
Second and
Yeah, wait. So, like this? And let's see what we have. Yeah. So now it's looking like this because it's actually still using the previous variables, so it's still using these ones in our rotation. So we just need to switch them. So we need to take these ones and actually use them. So you just go into every rotate function and you say our angle. For the minutes, it will be minute angle. And then the same for the seconds. And the milliseconds. And then we do get our fraction thing going. And I think the mistake that I made was that I had my division in the wrong place. So separating the thing in two steps actually does help. Does everyone? Yeah, but mathematically speaking, you first do whatever is inside your parentheses, and then you do your division and your multiplication. But if you don't have that, it will divide the number first and then sum it up.
Ja, dan het 1 plus minuten,
Ja.
gedeeld door 12, plus, dus,
Yes, and you really need to be careful because that's also the mistake that I made in the beginning. That like I was just doing the calculation in one line and then it didn't really work. Moet ik iemand helpen?
En het is gewoon hier op een woordje op het houden. Dan een nieuw woordje. Like it's important to know in certain things it seems easy, and then once you get into it, it becomes a bit more complex. Also, note the only way that we could solve it today, and the only way that I could solve it yesterday as well when I was making it, is by splitting it up, by not trying to do everything in one line or making it more complex, but by introducing more variables like a fraction. Those sometimes take a bit of time to think about, but if you do it, it becomes much more clear.
Well, now that you have a clock working, you can actually try and tweak it, make your own design, maybe use an image as a background or add sound every time you reach a certain hour, for instance. So there are a lot of ways you can go further with this. Yeah, I don't know if we can do one more or. Ja, het is al 1 uur. So we have seen 2 very extensive examples, but I think you have learned a lot of principles that will really help you to go further. I already saw one person, I don't know your name, but you used an image already for your Flappy Bird, so that is great. I don't know your name, I'm sorry.
Ezra.
Oh, Ezra, okay. So Ezra has used an image already, so maybe that's something that you can start implementing. Also for the clock and the Flappy Bird, you could also use sounds, which is something that is quite cool in P5. There is a synthesizer thing that I need to learn myself, but it looks really cool because you can create your own sound, I think. Yeah, I'm very bad at looking up documentation, but it's this, the oscillator, and in here you can actually, so there are waves of sounds, and I don't know anything about sound, but you have different waves and you can go high and low, and you can actually produce your own sounds with this, which can be cool for maybe every time you hit a certain hour, you hit like a keynote or it adds up, or you can use the logic that we have used to generate sounds dynamically, I guess. Also the same for images.
Mag je het een lesje, maar misschien daar even laten zien dat we dat nog.
Nou ja, misschien kan ik er gewoon eens doorgaan. Hè? So we still have a lot of examples.
Degene die wij al zien.
Yeah, so what we still wanted to show after this was a worm thing. What is it? Here, so you have a thing that generates a worm. And we used an array. I'm not sure, have we used it before? I think.
Ja, dat was het.
Yeah, so we haven't used the array thing before. Some of you have seen it in their own code. so you declare it as you declare a variable. So let's say R, for instance, and then you have to follow it with the square brackets. So there are a lot of different brackets that we use. This is the square bracket, which is a new one that symbolizes an array, and it's actually a new data type. So we have seen strings, we've seen booleans, and numbers, right? But this is a new one, and what this allows you to do is to store more than one string at the same time. So for instance, I have the word hello, and then I can write it as a string, and then I can follow it by a comma and say hello again, like this, for example. And in this way, I have two things that are stored in one container. So you can see an array as one container, and everything that you put in is actually indexed. So this has a number of 0. So it always starts at 0 because all computers start counting by 0. So this is 0, 1, and you can go on and on and on. And that's how we actually generated this, because every time you move the cursor, you create a mouse X and a mouse Y position, right? And every time I use my draw function, so every time I loop through the draw, I push my mouse and X position inside of the array. So this thing, the X pos and the Y pos, also has like functions that are built in that you can access, and you access them with the period here. So this is also just something native of JavaScript. Arrays have different functions that you can access. One of them is push, and what push will do is it will add one thing inside of the array. So every time,
At the end.
yes, at the end, yeah, it is important. And
So basically, we want to keep a history of all the points where we have been throughout our
yes,
mouse. So,
So-
we don't want to
yeah. So every time I push something, yeah, sorry. So it needs to be a number. So every time I push, I create a mouse coordinate of this, and then this again, and then this again, and this again. It just gets pushed endlessly for as long as this function runs. The danger with this is that it will go infinitely unless I put a limit on it. And that's why we have also created a variable called the maximum amount, which is 30. And in here, I have a while loop, but it actually also works with an if loop, because this is a thing that just keeps going. So a while loop we haven't seen, but we can change this into an if loop and it will still do the same. But essentially it just says that while the length of the array is bigger than the amount, you shift, and shift, what it does is it removes the first element of your array. So every time you get more than 30 elements, it will just start removing this one. And then,
basically removes the oldest
yes,
from that new.
and yeah, thanks to that, you can see that there is only a limited amount of circles available, and that's why you get this trailing thing. And then we have, yeah, and then you can see that also the circles go smaller and smaller and smaller until they disappear. And there is also like an opacity, and that we do with the loop essentially. And every time we create a circle with an alpha value, and the alpha value will just decrease every time.
The most important part here is the position. So instead of saying this is a fixed position,
Oh yeah,
use X plus
yes. So in here,
minus Y equals the element from that X position that's the element from the Y position.
yes. And the length equates to the total amount of elements inside of your array. So this, the total length of this would be 1, 2, 3, 4. So the length of this would be 4, and as long as the I is smaller than 4, it will iterate through the loop. So it will count. In here, it will do 0, 1, 2, 3, 4. And once it gets to 4, then it will exit the loop. So this is also something that is super, super useful to create an array where you can store things and then you can iterate over them and just make them change inside a loop. So we crammed this in super quickly, but I don't know if you want to add something.
Yeah, there's tons of examples that use lists. Yeah, I think this
Yes.
is super useful for that. Lesson number 3. But there's more stuff for lists. We're also used to images. For example, we have this animation. So the animation itself is also a list of images. So we do choose.
And I think the main important thing with images is that you have to load them before anything else. So there is like a new function that you have to use, which is called preload. So you have to load your images there because there is something called asynchronous behavior in JavaScript, which you can look into, but it will wait until the things in the preload are loaded before continuing on to the rest of the functions. So you load them here inside a variable, and then we do the same where we have a lot of images.
Also,
Yes. Yes, so they're being pushed here. And then inside of the loop, we have a modulo again. Wait, let me zoom in. Is this a loop? Well, it is a loop, but not really a loop, like the draw function. So every time the draw function runs, there will be a different modulo counting from 0 to 5, I think. So then you can create this kind of animation. I have an example of this, which is this, which I really like. So I'm planning to use sound for this. I don't know if you guys know Copycat, but it's really cool. So every time I press a key, I just get a random image from my array. And the one thing that is very important in this image thing is that I have my image named in a way where I can loop through them. So it will start at 0, 1, 2, 3, 4. And in my sketch, yeah, this is a bit. So in here, I used my template literal as I showed before, and then instead of the number being one fixated number, I have like a variable, and that's like my x that will go from 0 to 5. So that I get all of my images loaded in. So that is actually important that you name them accordingly, because then you will get some errors that don't make sense, and you will be stuck for a while because I've been there. And then, yeah, and you can do a lot of stuff.
there's more examples of video and stuff.
Yeah, we didn't get there.
Yeah, if there's a question like normally it's people who don't do it's sort of nice when it's
Actually, review
super.
So that's me. So it just works with the theory of images are based on pixels, and we know the location of every pixel, so we can actually modify every pixel. And we can get the color, I think, or maybe the range, and everything. Yeah, the brightness, sorry. And then according to the brightness, we can change it to whatever. But all of these examples are here on this page. Yeah. And then we also have the cool ones. These are like
Volgende week hebben we plaats van fysical en dan daar hebben we pas. Allemaal hebben we al voorbereid.
well, thank you, Marijke. I think we're gonna stop the live, right?